can't even explain it to you. Sir, please, could you just, I think for the benefit of this podcast, I think we should get the nomenclature out of the way. If you could perhaps explain to me what exactly are the different periods, starting with the Triassic, Jurassic, Cretaceous period, and what exactly do you specialize in, and what are the things that we can talk about today?
Okay, Shubhankar, thank you very much. And it's a matter of great pleasure and honor for me to be here and interact with you. The thing is, the Earth originated some 4.5 million years back, billion years back. That is 4,500 million years back. And when you know the first slide that appeared, that was around 3,000 million years back. And the first slide that started appearing, it was some sort of a single-celled organisms and multi-celled organism that went on multiplying, mostly trying to live in aquatic environment, waters and all that. And then these were these organisms. And then with these organisms, it gradually evolved to some sorts of invertebrates. So if you look into the history of the Earth, right from 4.5 billion years till today, the entire geological history is divided into different eras. Earlier, what we call is Precambrians or Archeans, before which the life was not there. And the first era which comes, it's starting around 540 million years, is what we call it as a Phanerozoic era. That includes your Permian and Cambrian and Devonian and Silurian and things like that. And after this Phanerozoic era, we have a Mesozoic era. Okay. That includes basically the lower one. We call it in a stratigraphic order as it is going up or younging. So we have Triassics, we have Jurassics, and we have Cretaceous. Right. This is the Mesozoic.
And Mesozoic period is the one that is the one that we celebrate, we see in films, and this is the part where we discuss the most.
Yeah, because it was basically the age of the reptiles.
Yes.
Because and then after Mesozoic we have Cenozoics, where we have entirely different types of plants, different types of animals, and mostly dominated by mammals and birds. Other than
this, you're talking after the event.
After the event, I am talking of a Cenozoic. As I did with Phanerozoic, Mesozoic, and Cenozoic.
Okay.
So Cenozoic comes what we call it the global extinction. At Cretaceous tertiary boundary.
The 66, what happened 66 million years back.
So basically when they started from multicellular organisms, the first things it evolved into the invertebrates, and then from invertebrates it came the first fishes, what we call the ages of the fishes.
So could you explain what is vertebrate, invertebrate? As in, I understand that it means that having a backbone, right?
Yes. Vertebrates are only the animals which have backbones, as you rightly said. But there were some fishes which had no bones with them. What we call it a Saurischian, Elilosmebranchi. There are many fishes. We do not have bones there.
Okay.
But from those fishes, the Saurischian or Elilosmebranchi fishes which had no bones, they evolved to the bony fishes. So this was the age of the fishes that came around 410 million years or something like that.
This is the earliest form of life
vertebrates.
We have. Right.
Vertebrates.
Right. Okay.
Okay, and then after the age of the fishes, we have these fishes evolved into the amphibians.
And amphibian, what is the definition of amphibian?
Amphibians is basically they are amphibians. They were able to live both on the land and in the water.
Oh, okay.
That's why I call it amphibians. Okay. So all your frogs, salamanders, they are all amphibians. Okay. So because which had an advantage when from fishes they evolved to amphibians, because they were basically egg-laying animals. Okay, when they were egg-laying animals, the amphibians and fishes, they were laying eggs in the water only. So from the age of the fishes to age of the amphibians to they evolved to age of the reptiles. So this is the age of the reptiles that still continues. Okay, and the reptiles had a advantage that they were able to lay their eggs even on the lands. And they had a better opportunity because reptiles means there were many different types of reptiles. So they were also gradually said in the Phanerozoic era, the topmost, if you look at the Permian, we have some vertebrates, we call it mammal-like reptiles, from where the dinosaurs evolved.
Mammal-like reptiles.
Mammal-like reptiles.
So you mean to say that at that point it branched into dinosaurs and mammals?
Yes, you can say that. But we had the reptiles. We have the mammal-like reptiles. When I say mammal-like, they were a molarification. Because generally in the other reptilian groups, when you see, their teeth are similar.
Okay.
But when we say molarification, you get canines, you
molars,
get incisors, molars, like that. So those particular reptiles, we call it primitive reptiles, or theropsid reptiles, or mammal-like reptiles, they were the one from which the other advanced reptiles that emerged.
But these mammal-like reptiles, were they laying eggs or were they birthing?
No, it is, we really don't get eggs of that time, if you go back to Permian that time.
Okay.
But then it is speculated. Because most of the reptiles, they lay eggs only. No reptiles give birth to a young ones.
Exactly.
Live ones. So it is presumed that they were laying eggs only.
Because I was reading about mosasaurs.
Mosasaurus, yeah.
When mosasaurus used to have a calf.
Calves, yeah. But it was a typical oceanic.
Exactly.
Yeah. Because before that, we have mosasaur, phytosaurs, ichthyosaur.
Yes.
They are typically oceanic things.
Right.
Okay, and when these reptiles, they started evolving, as I said, in the age of the reptiles. Within the age of the reptiles, because there were different types of reptiles, and within the reptiles, we have the typical dinosaurs. So these dinosaurs, they differed from other group of reptiles, like say crocodiles,
turtles,
snakes, turtles. So they differed from that. And they say that if you look at the dinosaurs and you look at the reptiles like crocodiles, they had some sort of a sprawling gait. Their limbs, front limbs and the hind limbs, they were outside the main body.
Right.
That we call the sprawling gait.
Okay.
But where the dinosaurs, as you look at, they were the columns like straight just below their body.
Either four limbs were touching the ground, or
ground.
Two limbs were.
Two limbs, yeah. But they were almost straight.
Bipedal or quadrupedal.
Okay. And these dinosaurs, they had also advantage because they are both shoulder girdle and pelvis girdles were very strong.
Okay.
And also their neck was very strong.
So pelvis had to be strong because they had to stand erect.
Because they were both bipedal and quadrupedal. And if you have a sauropods which may run in 60 meters, 70 meters like that. So they had to balance that.
They had a huge
yeah,
neck
exactly.
Also.
Some of them, they had big necks. And they will have different types of necks. Some of them will be straight. Some of them will be very vertical, inclined. Their body will also be like, some of them, the body will be almost horizontal. Some will be little arched. Some will be typically sloping. So they have to just balance. It's not only standing, but they'll be walking, running, they'll be hunting, they will try to graze.
So the ones that were running were the ones that were standing on 2 feet?
No. Even some of the quadrupedal, what we call, they were also trying to, you can say not exactly running very fast, but they were naturally, they are very
So, but my
moment.
question is that we identify most of the sauropods or the quadrupedal dinosaurs as herbivores.
Yes.
And most of we're talking about the T-Rexes or Rajasaurus, which were
they're bipedal.
Theropods, which they used to run on 2 feet.
Bipedal, yeah.
So bipedal. So then they were carnivorous.
They were carnivores, yes.
Right. So what did the sauropod had to run from or to?
They have to run because sometimes when the theropod is trying to predate on them, they will try to escape.
Okay.
And as you rightly said, when we talk of a theropods bipedal, basically carnivore, trying to hunt, predate the other animals. Yes. But some of them, they were also scavengers.
Okay.
They were not really killing others, but some dead bodies available,
right.
they will thrive on that.
Okay.
And within that, if you basically look at the classification of the dinosaurs, we have two major classes. One we called is a Ornithischians, bird-like,
Yes.
because their pelvic structure was like that only. The backbone and the pubis bone was there.
Like a chicken.
Like a chicken, birds-like pelvis. But if you look at the what we call is the Saurischians, these Saurischians, they include what you said, both sauropods and theropods.
So reptiles.
They are typical reptiles, like where pubis bones and ischium, they were forward. Directed.
So, what kind of bird-like dinosaurs do we know about that existed in India?
Actually, bird-like dinosaurs, actually, if you take into consideration the dinosaurs, they never become extinct. That's why when we try to describe the dinosaurs, why you call it non-avian dinosaurs and avians. That is aves. Aves means birds.
Yeah.
So when you try to study the taxonomy of the fossils and the transition between the dinosaurs and the birds, the birds, they evolved from a theropod dinosaurs only.
Oh, of course. I mean, had to be.
They evolved from that because there are some reptiles, some dinosaurs rather, which have some feather-like structure.
Right.
Because if you have heard of Archaeopteryx,
No.
Archaeopteryx was some of a transitional fossil between the dinosaur and the birds.
Okay, so there is a fossil of an animal that is transitioning from being a dinosaur to a bird.
Yeah. So that is from the Jurassic.
So this transformation was happening in the Jurassic period.
Jurassic period, yeah.
Oh.
They were trying to evolve that.
Okay.
So in that, it was a very intriguing fossils because that particular animals or that particular dinosaurs, when they collected from the Jurassic in Germany, Salopan they called it. So that first skeleton which was collected, it was not complete. Right. It was partial. So Britishers, they purchased it mere for 700 pounds. And it was taken to their museum.
This is the Natural History Museum.
Natural History Museum. And then, but it had a missing skull. But feathers were beautiful there.
So they had preserved feathers?
Feathers in that. But then it was not complete, so they were not really able to see a relationship between the dinosaurs and the birds. Because they got a link, but then many characters were missing.
What is the name of this specimen?
That is Archaeopteryx. Archaeopteryx.
Oh, wow.
Okay, and then within or rather less than a year, they got another specimens. In Germany itself, from the same stratigraphic horizon, which was complete. A beautiful specimen.
So stratigraphic horizon would mean the same slab,
which was deposited during the same time period.
Okay.
That we called stratigraphic equivalents.
Okay. But there was still maybe thousands of years of difference between one specimen and the next.
We don't know, but as reported, it comes from the same rock types, from the same lithology, and from the same stratigraphic horizon. When we say same stratigraphic horizons, we have to assume that no, it comes from the same time period. Exactly. So when they were trying to study that, they found a difference between the dinosaurs, as you say, like a theropod,
right?
And they were trying to study some real birds, rather you can say extinct birds, which were living birds, and they found that these Archaeopteryx fossils was different. It has both the characters of the birds and the character of the reptiles. The characters of the reptiles means they had a teeth in their beak. Okay? And all these beaks in the teeth, they are in the sockets.
Oh.
And because sometimes you get the teeth, but they are in the grooves.
Okay.
But these reptiles, they have a tooth in their socket. These Archaeopteryx are made. Okay. And the other thing was that they had a claws. Big claws.
Oh.
So that was another advantage.
So claws would mean they were also hunting?
Hunting, yeah. Definitely. Because there are many birds which you see, they are carnivores. Some birds, they typically live
like eagles and all of that.
Yeah, exactly like that. And also they had a very strong tail as well.
Okay.
Caudal that, because they have to also balance and things like that.
Okay.
So some characters of the reptiles, and for the birds, they had feathers and they had a wishbone. Because only birds have wishbones. So these two characters, it was a transitional. So that was a Jurassic Archaeopteryx from Germany. But later on, many discoveries, especially from this, you can say Gobi Desert.
Okay.
Gobi Desert, if you to look...
Is in Africa?
No, Gobi Desert in a part of Mongolia.
Mongolia.
It's part of Russia, and then it's parts of China.
Okay.
And this during this Gobi Desert, when we say Gobi Desert, the life and the dinosaurs that existed, they were entirely different. Like time, mostly the arid and desert-like conditions.
Right.
So wherever you're getting the dinosaurs in these Gobi Deserts, there mostly you get beautiful and complete skeletons. The reason is because no sooner those animals or dinosaurs they died, they were covered with the sands.
So I was reading about this. So they were not just the sand dunes, but there were also gypsum dunes and other.
Gypsum dunes. So the thing is that when we bring a arid conditions, because you have to be very arid when we are trying to, just say you say in Rajasthan. Or your Sahara Desert.
Thar Desert
or Sahara Desert, Africa. The things will be extremely arid.
Right.
So during these arid conditions, during these arid conditions, you get a typical mineral which precipitate in a very high temperature, where even the water bodies will be there in that desert, but they will be excessive evaporative conditions.
Right.
Excessive evaporative conditions.
Right, because it's so hot.
It is so hot. So if you are getting the excessive evaporative conditions, the water will be almost like brine-like. The salt will start getting concentrated into that. And it is here that gypsum starts forming there. It precipitates there. So most of the gypsum when you get, it tells you that it has deposited in the excessive evaporative conditions or hot conditions. Or some sort of arid conditions. So it's not necessarily that gypsum always precipitates in the arid or in the deserts. Because here also in other continents, even in India, if you go, there are many lakes. And these lakes, they enjoy different monsoonal-like conditions. Varying climatic conditions. We have hot sun and then it becomes arid, evaporative conditions. So there during particular period, you start getting these halides and as you told gypsum like that is stuff. So it tells you the thickness, what type of environment existed that time and what type of life was sustaining.
And Earth was generally a little warmer during the Jurassic and late Cretaceous period.
Cretaceous it was much there, but if you look at the Jurassic, because all our coal deposits they are coming from that.
Right. Okay. So the coal that we are using today, that is plant.
Basically, it's a plant.
But it would also have fossil?
Yes, definitely. Fossil roots we get. Because it's a decade. When you get a plant now, this material, and if the entire forest, it gets buried. Right. It is not to be exposed. It is to be buried in a very reducing conditions.
Right.
So when this, the woody tissue and all, they get carbonized. And if they are exposed, they become a fossil roots, and that's what we call petrification. It's all silica which comes and that's why fossil roots are different than the coal which you are getting.
Right.
So
I think we spend so much of our time thinking about the fauna of that time, but what was the flora like?
Yeah, exactly.
Especially in the Indian context.
Indian context, if you see everywhere in the world, you see if you look at the paleogeography of the land, as I was telling you, during the right from your Phanerozoic to Mesozoic Jurassic period, if you look at that, the different continents, what we call it is Superpangea, they were all there together.
So Superpangea was when the entire landmass started as one big continent.
A big continent.
Right.
So that time, if you look at the animals, including the dinosaurs there, they were migrating very freely
roaming
all around.
Yes.
And later on, as these different land masses, they started separating. Continental drifting.
Yes.
So the northern masses and southern masses. Yes. When I say southern masses, which we call it the Gondwana land.
Yes.
So that is South America, Africa, India, Antarctica, Australia. These are the southern land masses which form the Gondwana.
So South America and Africa were basically one
exactly. And then it started drifting. There were many oceanic barriers which came in. So whatever dinosaurs and plants, they were that time when there was only one type, one landmass, connected landmass. These animals, they were freely migrating.
This was during the Jurassic time.
This was Jurassic.
And by late Cretaceous, we had separated from Madagascar and and bumped into
Asia.
Yeah, that is how the Himalayas are.
Himalayas came. That is much after. But if you look at that, as the Gondwana started splitting into different continents, and India started splitting away from South America.
Right.
So if you look at that now, before it splitted, all our dinosaurs, fauna and flora, they are almost similar to that level.
Okay.
So
all over the world.
All over the world. If you look at the Triassics, where you are looking at the Gondwanan or you are looking at the Northern Europe.
Triassic is the earliest.
Yeah. That time they were not split up.
Right.
So they were similar, you get. But then you see, basically when India separated, we still retained very, very close to Africa, eastern coast of Africa. And we maintained our connection with the Madagascar and Seychelles.
Seychelles, right.
And then we were migrating, and with Madagascar, we retained our connection at least till 90 million years.
90 million years.
Yes. And we had separated from the other Gondwanan land masses around 110 million years.
Okay. So meaning that we at the time of late Cretaceous, we were an independent continent.
Exactly.
In the ocean, slowly shipping towards Asia.
Yeah. So in around 90 million years, we have severed our connection with Madagascar also.
Oh, okay.
And then it was India's singular flight.
Okay.
Going northward.
As a independent continent.
Peninsular landmass, it was migrating.
Okay.
And it went on migrating. You can just imagine. Right from 88 million years till it collided with the Eurasian plate. Right. And that was around 55 million years.
Right.
There are debates among that, but it's 54.
But after the event.
So this is, whatever we are getting, the history of this, that is at least 10 million years before the Himalaya came into existence. Okay. So all your dinosaurs, they were much before the Himalaya. It is 10 million years older to this.
Oh.
And as you asked a very interesting question, as you said, because the dinosaurs were not the only animals. And both the animals, fauna comprised, and then the flora was there. We had different type of flora, and very different type of animal. Dinosaurs were never a single. Along with the dinosaurs, there were many different other reptiles. Crocodiles, turtles, fishes.
We'll come to the snakes.
The snakes. They were all living together. Yes. So it was a definitely different type of ecosystem, climatic conditions, which were much favorable for as a habitat of all these reptiles. Right. In most of these reptiles, they are cold-blooded reptiles.
Right.
Cold-blooded and warm-blooded. So they have to maintain their temperature. Cold-blooded and then warm-blooded. So all these reptiles, they have to maintain their body temperature.
Which meant they ate less.
Yes. They ate less because they don't need, because their rate of metabolism will be very less.
They don't have a fire inside.
So they all the time they are not to. And many of these reptiles, amphibians, if you look, and crocodiles, even if you go to the zoos and all, they feed them once in a week or something. They sustain it for a week.
Right.
So, because they really don't need that much of energy to sustain. And similarly, it is for the dinosaurs as well. Because we are very large. 40 tons, 50 tons of dinosaurs. 30 meters, 50 meters, 60 meters, Super Gigantosaurus long. Titanosaurus and Brachiosaurus, Super Gigantosaurus and things like that. So, how much they will need? Because if you roughly look at some herbivore mammal, say your elephant. Elephant, it needs a lot.
Right.
So it will consume more than 10 times its weights in a month than the comparatively, because it has to keep running. Itself running and done that sort of temperature.
So, but then if these dinosaurs were cold-blooded, the recent illustrations that we are seeing are them being a little, chunkier and fatter. And we are seeing that Tyrannosaurus Rex is not what we saw in Jurassic Park. This guy is really heavy. And he could be an ambush predator, not a running predator.
Exactly.
So, if he was cold-blooded, then why did he need so much food?
It's a very interesting question you asked, Shovankarji. Because, there is still a debate and controversy.
Okay.
Where these dinosaurs, say sauropods or theropods. Sauropods, of course, if you presume that they were cold-blooded living herbivores and things like that.
They were like the giraffes.
Like giraffes, yeah. And if you look at the theropods, like Tyrannosaurus you said, or there may be Rajasaurus and things like, if they have to run, they need a lot of energy. But they are not really able to prove so far. Because if you make a modern warm-blooded or endothermic animals, and if you study the histology of their bones, they are entirely different structure.
Right.
So they tried to study, made the histological study of the bones of these sauropods and theropods. So when they are trying to run and they are warm-blooded, they created lot of what we call a Haversian canals in their bones.
Like cross sections.
In the cross sections.
Okay.
What we call osteons and Haversian canals like that. But confirmatively, still that debate goes. Whether they were. Then someone came with thermophilic animals in between warm-blooded and they cold-blooded that. So that controversy continues. But so long if you look at the living or extant reptiles, none of them, they are warm-blooded. Including your snakes.
Right.
If you look at the big size anaconda and python, they eat a lot. But once they eat, they as good as hibernate. They don't need anything.
Yeah.
You see amphibians, cold-blooded.
Right.
But it's for 6 months they will be there. Hibernating. They will not come out till the monsoon comes.
Yes.
So they really don't need that sort of thing. So during the age of the reptiles and during the age of the dinosaurs, we had different types of flora as well that existed that time.
But did we have fruits?
Fruits, I mean the flowering and fruit plants, they appeared much later.
Right.
They appeared almost, you can say, simultaneously with the dinosaurs.
So there was no mango tree?
There were no mango tree, much came later. But you know, it's very interesting because you are asking when we are working in your Pisdura, the Chandrapur district, near Varora. Just before that, we speak about that, I will just tell you. Because we are talking of the dinosaurs. As I said, the older line, southern masses, Gondwanan dinosaurs, they are much older. So whatever dinosaurs you are getting during that time, during the Gondwana times, till say 140 million hours, even up to that, you have a different types of dinosaurs.
Right.
But those old dinosaurs, they are not that well preserved. So we get the oldest record from Pranita Godavari, a theropod dinosaur, Avakaria and things like that.
This is the Triassic period.
Triassic period, Malari formation. And then you get around 220 million years, you can say. And then from that, it's not a very continuous record of dinosaurs in India.
Yes, I was going to talk to you about the gaps in the stratigraphy.
Yeah, there are gaps there.
Yes.
So they become some sort of an episodic. So sometimes there are so big gaps. Sometimes you have a 30 million to failure, what we call the gap. So where we really don't know what was happening to those dinosaurs there.
Like we know what happened in episode 1 of a TV series. And then we directly have episode 57.
Exactly.
We don't have the
in between.
Right.
So, but as you said, the Gondwanan dinosaurs, that time, whatever way they were there. And you know, though we have many dinosaurs coming in different ages, we have Triassics, Jurassics. When I say Jurassic, the best dinosaurs that when you date from Jurassic horizon, around 140, 150 million years, they come from Pranita Godavari, Gondwanan, and they had given the two best dinosaurs to India. One is Barapasaurus and one is Putasaurus. They were almost contemporary. They were early sauropods. And these are the only two skeletons. One is Barapasaurus, that in Indian Statistical Institute, SLJ and Kutti, T.K. Rai Chaudhary and Pamela Robinsons, who excavated, worked on these specimens, and they described Barapasaurus. And this Barapasaurus, it's not a complete skeleton. It's hardly 40% skeleton. Even that skeleton is with a missing skull.
So how do you, this is something I was coming to, that you are finding these very small bones and pieces, and it is almost like doing a very difficult jigsaw puzzle.
Exactly.
Right. So when you're putting them together and now you don't have the skull also.
Yes.
How do you So just break down the entire process of how do you go about solving this really complicated jigsaw puzzle? How do you piece these things together? How do you imagine?
Yeah.
What goes in?
Yeah, Shubhankar, when you, as a geologist or paleontologist, when we go and try to hunt for the fossils, maybe for dinosaurs or maybe some other vertebrates. So you see, these are all fossils, they are coming from the animals which were living once upon a time.
Right.
So there was a death of an animal, it died there, and when they died, there may be other scavengers which trying to live on the skeletons. Someone can remove the limb bones or hind limbs.
Okay.
So if you want a near complete or better preservation, we need to see that animal is buried immediately.
Right.
Under the sediment. Sometimes these skeletons, they go into the river, they are transported. So the hind limb goes somewhere, right goes somewhere, left goes somewhere. So it's very difficult to get as far as the complete skeleton, or they leave apart the entire skeleton. In China, as I told you, Mongolia and because no sooner the animal died, they were all covered with that.
Right.
So there was no
With
chance
the
of time. So there is a big between the death of the animal, the burial, and the fossilization.
So, but then isn't that a benefit for India because of the Deccan traps, the volcanic traps?
Deccan traps only helped us because they protected the fossils which were already there.
Okay, so the volcano happened later.
Later, yeah, definitely.
Oh, okay.
Sometimes some of them were seen volcanics. So when you look at these animals, as I told you, the best Jurassic dinosaur, Barapasaurus, Cotasaurus. Barapasaurus is kept in Indian Statistical Institute, Calcutta. And Cotasaurus, the Geological Survey of India by P.K. Yadgiri Saab. It is there in Hyderabad. Nehru, that Birla Science Museum, it is there. And you will wonder, this Barapasaurus, it is constructed, because you asked a very interesting question, it is constructed, not belong to one individual. There were many individuals, we were mixed together. So we try to pick up the bones of the animals which were almost similar age. Okay. So sometimes you have a right leg, sometimes you have a left leg of different. And we try to, as far as possible, to reconstruct. And if you have a left leg, we try to reconstruct the rate. People try to prepare the contemporary.
Like a mirror image.
But as I told you, because the skull, as you said, that is missing, say Barapasaurus.
Right.
So in that case, we try to find the nearest match. Because I said at that time, during this Jurassic period, we were very close to the Africa or South America.
Right.
So that time, what were the animals? Or sauropods, early sauropods which were there. We tried to bring this. So there was a South African dinosaur, that is Volcanodont, that was early sauropod, which was almost close to that.
Okay.
And that's why the skull was put there in the Barapasaurus.
Okay.
So actually the bones are less than 40%, our other bones are assembled or reconstructed. But as far as this Cotasaurus is concerned, it is constructed of all 12 individuals. Of the same age, of the same size.
And how does this aging happen? How do you know so specifically that in that era, millions of years ago, this was a subadult, this was a fully grown male?
That will only depend on the size. Because where there will be various parameters. Because when we try to study, say, femur, or we are trying to study the humerus, or we are trying to study vertebrate, the morphology or these measurements of this particular element, it becomes very important for us. So based on this morphometry, we are able to classify. We cannot exactly say what is.
But the minute you look at a bone, you immediately know that this is a femur, this is a vertebra.
Yeah. Okay. Because sometimes it's very difficult that you get the entire femur. You may get only very proximal or distal. Then you try to, but there may be some other bones which you get that may be only proximal. So we try to reconstruct, but often we get these things.
So how do you exactly piece these things together?
When we see, say Jabalpur, where we get usually in India, if you go to, as I told you, Jurassic only Pranita Godavari, Barapasaurus, Cotasaurus, these are all the Gondwanan, oldest dinosaur which we are getting in India.
Right.
Based discovery. Then we go to Cretaceous, rather the late Cretaceous. Okay, late Cretaceous and the upper Cretaceous, that maybe I will put something around
72
to 66 million years like that. Okay, so when we go to that particular dinosaurs, these late Cretaceous dinosaurs in India, as you had just a few minutes back you asked me, they are all found with the Deccan volcanic associated sediments. So Deccan volcanism are the big volcanic eruptive events that lasted from 69 million years to at least 64 million years.
Okay, so they overlap the event.
That overlap the event. And when this event was there, and that's why, because it was such a long span when the duration of volcanic eruptions was going on, but it was in pulses. It was not that it was coming up and
some volcanoes, then another,
and then India. It was a much bigger continent that time.
Right.
And if you presume that, Shubhankar, India before it collided with Eurasia,
right,
the continental mass was much bigger.
Right.
So before the collision and after the collision, India has reduced much.
Okay.
Because much has gone into that under thrusting.
Oh,
below that.
Okay. So you're saying that when it crashed,
yeah,
a big part of the landmass went underwater. Oh.
So we lost many of the land. It was a much continental mass before that. So much continental mass, and they surrounded by Tethys and that time. The climatic conditions were also entirely
must
different.
have been really hot.
Very, really hot, different, and coastal areas and things like that. So what happened that time when the Deccan eruption started? What we call reunion hotspot and all. So there was a volcanic plume which was erupting, and India plate, it was migrating over that.
Okay.
And if you look at this Deccan volcanic rocks, trap rocks, it occupies nearly 500,000 square kilometers in India. It's such a large size.
Can you tell me the exact places on the current map? This is Rajasthan, Gujarat, MP.
That's what, when we talk of Deccan trap volcanic rocks, they have been classified and divided into different sub-provinces.
Okay.
Once we say a mandala lobe, so that comes in Eastern Deccan volcanic province, Eastern map. That constitutes your Amarkantak, Jabalpur, and then Mandala. Chhindwara.
Okay.
So this entire Mandala lobe. And then we have Malwa Plateau, north of Narmada. That is another Deccan volcanic province. Right. And then you have Western Ghats. Complete. And then you have Mumbai volcanic, they are entirely different. And then you come to Peninsular India, what we call it the central provinces. So these different provinces, even your Kutch and Saurashtra, they had the different sites and source of eruptions that erupted different times. The duration was different.
Okay. So there was no Thar desert at the time.
That Thar desert came much later.
Much later.
So if you look at that, so different provinces, different areas, and when we were getting the sediments, they were getting deposited, say dinosaurs, living during that time when the first lava flows came.
Right.
They will be very fatally affected.
So you're saying that even before the extraterrestrial event happened in New Mexico, the Indian subcontinent dinosaurs were already dead.
That was our major input which we gave. So there is a major controversy because as far as the extinction is concerned, and as I said, Deccan volcanism. Deccan volcanism, it started, and your dinosaurs, they were throughout. As I said, Jabalpur to Ahmedabad, and then you are coming south. So if you look at that, see, there are the dinosaurs which was prolifically occurring. It was in the Kheda, Panchamahal, Jabalpur.
Right.
And then you have Pisdura, Jabalpur. They are the main, Jabalpur and Chhindwara. These are the three. You can say Kheda belt, and then you can say your Jabalpur, and then Pusdara, Dongargaon, from where maximum dinosaurs are reported. But if you look at the dinosaurs, at these three areas or three different provinces, they may witness the eruption of Deccan traps in time which were temporarily separated. Gujarat witnessed the eruption of volcanoes much earliest.
Achha.
Okay, so naturally the dinosaurs, when they saw the adverse effect of this volcanism, gases and then photosynthetic and lot of warming up, and
there must be no sunlight for a very long time.
Sunlight, yeah, definitely, because it will all be covered the volcanic ashes and things like that. So naturally they were trying to escape or migrate to the safer areas, away from the eruptive centers. So if you go to Gujarat, the dinosaurs, they may be late Cretaceous. What they are mostly getting, the sediments which were deposited just before the advent of Deccan volcanism in that particular local area, we call it limita sediments. We called limita of sediments which were deposited in different provinces. But these limita formations, they are different. What we got time transgressive. Some were deposited earlier, and then when they migrated, if you come to your Dongargaon, Pisdura, in
Central
Province, they are different. Jabalpur, if you go, there is a magnetic crown, 67 million years and something like that. Paleomagnetic crown. So most of these dinosaurs, they live during C30 normal. That is the earliest Maastrichtian event. Maastrichtian is the last in the late Cretaceous. Okay. So within the Maastrichtian, this is the earliest Maastrichtian. Then we have 30 normal, we have reverse polarity. And then again we have normal polarity.
These are talking about the different periods.
Different period, but within the Maastrichtian. Because just before the advent of Deccan volcanism, in Jabalpur, if you go, the dinosaurs, they are different age, very close. Within the Maastrichtian. Maastrichtian is not a very, very big period. Okay. And Jabalpur, your Kheda dinosaur or Gujarat dinosaurs, they are oldest. In the late Cretaceous, then your Jabalpur.
So they came to Jabalpur.
Jabalpur. And then before Jabalpur, if you come to your Pisdura area, Dongargaon area, there you get a mixed from normal to reverse. So from here, in between the Jabalpur and the Kheda, you have the dinosaurs which lived in Pisdura and area. And you just before that, you were telling about the Hislop and all. Hispos and Stephen Hislop and Brantford, they were the one who reported dinosaurs in the pre-independence in 1859. From 1859 from Pisdura area. And eventually...
And these were all the dinosaurs that were native to Central Provinces and also the migratory dinosaurs that must have run away.
So we are still trying to what must be the way, how dinosaur must have traveled or migrated. So based on that we can know. Because we have the relative ages of the rocks, which are dinosaurs bearing rocks here.
That is where the stratigraphy
comes. And though dinosaurs history, it is very interesting. Though the first dinosaurs in the world that was described in England, I think Buckland, it was in the year 1824. Even but it was recognized as dinosaurs
much
later in 1842.
In fact, there was a very interesting fact that you shared, which was that Barnum Brown,
yes,
the guy who discovered T-Rex, was also the guy who came to Jabalpur.
Yes, it was in 1922. So though the dinosaur bones in India, Colonel Sleeman, he found that first bone.
Sleeman is the person who pioneered Indian paleontology.
He was not a paleontologist. He was a British civil officer. He was basically identified and posted in near Jabalpur that was named at Sleemanabad.
To eliminate the thugs.
So that time they were taking a lot of interest. So that time he collected these bones from this gun garage factory area in Jabalpur, and he came across these two vertebrae. But this first dinosaur bones that was collected, it was in the year 1828. But it was recognized as dinosaurs only in the year 1877. Almost you can say after 50 years. It went through a series of hands. And it was Richard Ledecker, he described, these are definitely dinosaurs. That is how the first dinosaur, Titanosaur indicus, that was established in the world. So, and then you will wonder, and though the dinosaurs this is pre-independence, much before that, but in the same year, there was from the British Museum, there was a Percy Sladen Trust, when the C.A. Matley, Charles Matley, he visited India during two expeditions. One in 1917 to 1992 as he stayed, and one in 1932-33. So he had been, first time he went to Jabalpur, what we call Bada Shimla and those areas. And then he went to next expedition, he went to Chota Shimla. And then he also traversed the Pizdura.
And he collected a lot of
bones. And then the thing is that whatever we collected, those bones, chase of those
were lost.
Not lost, they were all shipped to Britain.
Achha.
They went to Britain. And many of those chase, it's not only to the museum, some of these bones they also found places in the market where they were being auctioned. And you will wonder, when the first discovery of dinosaurs came in 1828, that time also what we call it the shivalic fossils from Himalaya. That time there were big excavation going on in Yamuna Cave.
Okay.
So Falconer and Cotley, one was a botanist, who was trying to develop a garden near Dehradun, and otherwise Falconer and Matley. He was a surgeon.
Right.
But both of them, when that excavation was, they came across bones. They were much younger, 30 million, they were called shivalic fossils, sub-Himalayans.
Okay.
So they were much younger. Mostly you get big mammals like Shivatheri.
Okay, so these are not dinosaurs, they were not mammals.
But that time they were wonderful, along with the dinosaurs collected from the Jabalpur and which were being shipped to the British Museum. That time, many of these bones from the shivalics, they were also shipped.
The mammals were also sent along with the bones of the dinosaurs.
So that was very interesting. And some of these bones ultimately, they came back to it because that time Geological Survey of India, it was under British supervision. But many of those bones, they are still there in the British Museum, London. Like what has been described. So this is
and by the way, a cast of one of those bones was found in Nagpur.
Nagpur, yeah, that was a big thing because you wanted to really make an inventory. What are those fossils which were described in many of the collections which Matley has collected from Jabalpur.
Right.
So it was brought to Geological Survey of India, and there was the Indian Museum there attached where GSI is maintaining some galleries over there. So in that museum, he tried to take some best fossil skeletal collection.
Okay, like the best
collection he removed, but still there was something which were not even described. They were still wrapped. They were not even opened up. But when we looked at those wrapping and the original, still you find the labels written by C.A. Matley there. Within field number of that. So I was along with the Jeff Wilson. We had taken this particular project after finishing that snake project, where we trying to make the inventory.
Jeffrey Wilson is a paleontologist.
Paleontologist is there in University of Michigan. Paleontologist, curator and professor there.
So your relationship with Jaw is since the year 2000.
2000.
And you came in contact for the late Cretaceous snake, Sanajeh Indicus.
That was in 2000. Actually, this snake fossil, this time, I was when Jeff visited first time, and I interacted with him. That was in year 2000.
You also visited him recently?
Yeah. I have been visiting a couple of times there because we had that collaborated.
Okay.
Very recently, I visited in 23.
You went to Montana?
To Montana.
Okay.
So
let's talk about Sanajeh.
To Sanajeh. So this particular fossil, it was because as I told you, first dinosaur was found in 1828.
Right.
Pre-independence.
Right.
But that first dinosaur egg, which I discovered, I got National Mineral Award for that. That was in the year 1981. You see, such a big gap.
Yes.
Though the bones, 1928, you are able to. And that time there were many challenges because no one had seen what are the dinosaur eggs. Only bones were there. So even the stalwarts in paleontology, they refused to believe that this could be a dinosaur egg. Many strictures, because I was also not knowing.
So you were the first person who found dinosaur eggs in India in 1981. Was it just by chance or were you looking for them?
Now, first I will say it was a chance discovery.
So talk to me about that.
The thing is that, as I told you, I was a mapper. I was doing some geological mapping for the rocks much older than this dinosaur bearing sediments, what we call limit of formation. In course of that mapping, because we take different field traverses, so there was one transit very close to Balasinor.
This is
in Kheda district.
Kheda district. This is in Gujarat.
This is in Gujarat.
Right.
When I was doing mapping and when I was trying to, we do a lot of field work because mapping is all field work. We have to walk a lot and things like that. So in particular area when we wanted to go and there was a ACC query, Associate Cement query.
It was a cement quarry.
ACC query. They had a big mines there.
Okay.
And they had a plant there, almost 10 kilometers away from the Sevalia, and they were mining for the limestone.
Okay.
And this limestone, they were trying to improve the grade, removing silica, and they were taking it to Sevalia for producing cement.
Okay.
So in the morning when we reached maybe around 8:30, that mining supervisor, he said that no, please don't enter the mine because we are about to blast.
Okay.
They do a lot of blasting. He said that our blasting will be over in the afternoon. You can come up to 2 o'clock. So we said okay. So we just diverted. And then we came back because we parked our vehicle there. So they had already blasted that particular face of the mines. In one of the face, that all the debris and the boulder which were blasted, they were there. In one of the boulders, I found almost like described as a basket of eggs.
Okay.
It was a big piece of rock, but all the eggs, they were there together.
But were these eggs exposed?
Exposed. They were all spherical. I was not knowing
They were
that.
spherical?
They are all spherical, almost football size.
Oh.
And to my view, they were almost of the same size. I was not knowing because I had never seen eggs earlier, dinosaur eggs. And then I was wondering whether they can be, what could they be? And then when I find some of these fossils, they were like that basket of the same size, and they had some sort of a cover or layer on each those spherical ball-like object, almost 1 or 2 millimeter. Everyone has that type. So they were typical. I thought, can they be organic? And then when I was trying to look around, so many of the eggs which were broken, and they are the hinged eggs.
Okay.
Today, if you bring the chicken egg, and sometimes it's break, you find some shells just get hinged.
Yes.
So some of those eggs were preserved like that.
Oh.
So it gave an idea what is this. At first, I thought that can they be fruits also? I was not knowing. But then I thought if it has to be bunch of fruit, they should be of different sizes.
Right.
How can it could be
same
thing? And just before I entered, then I started recollecting. Just in maybe 4 or 5 days earlier, when I was transecting the nearby area, there was a place like Khempur, where I found on a surface ring-like
formations.
Ring-like drawings there, almost spherical rings.
Right.
Okay.
Right.
They were there, rounded, almost of the same size. I was not able to understand what they are. Rings of those things.
Right.
Cluster here, cluster there, cluster there. I was thinking what they could be. But I said that they are of the same size. They cannot be because there are many processes. Such things can form afterwards in the rock itself. They need not be organic fossil. The first of thing was whether they are really organic or whether they are inorganic or sediment, and they have nothing to do with the fossils either.
Like somehow that pattern has formed.
So then it clicked me there in Khempur also. I found what is this. So there it came, and then I started going around. So it was, I was feeling fascinated because I brought these eggs. And the first egg I brought, that time I was married in 1981 in summer, and my wife was there in those tentages. And
So you were living in tents?
In the tents that time, 81. We call Swiss tentages. And then in the box, I asked my labor to get that chunk of those partial egg clutch. And then I put it in front of my wife, she came, she told me, "Aap to bahut late ho gaye." I said, yes, today it was very interesting. I told her, what is this? Does it look like, what do you think about it? She said, Baba, I really don't know. But they are all same thing. To me, they all look like footballs or something like that. I really don't know. So it was the first egg which my wife had seen. And later on, I was just like...
That was the first egg anybody had ever seen.
Any had ever seen. Yeah. So, but still damn, the identity of egg was not proved. It was only I was doubting whether they are eggs or they are some fruits. And if I thought that if they are eggs, they have to be dinosaurs because they were so big, 18 centimeters, almost of a football size. Because only the reptiles which lay eggs, birds were not known. And I knew because these reptiles exist in limit of formation Jabalpur, as they were already reported.
So you had some information that
dinosaurs were there.
Dinosaurs were there.
Lived that time. But I had never seen the eggs. Only bones I had some chance to look at. So I think in case if they are eggs, and they are the reptile, it could be of dinosaurs. And fruits I was on. So I was trying to study, no one had seen, then my director visited. And I showed him. So this is the thing I collected. So what do you think? I said that I really don't know. But to me they look like my preliminary curiosity, they look like eggs to me. Because if you look at that, they are almost like a basket of eggs. Like that, and I was telling you those things. He said that I really don't know because even I am working. So then he took in his car some 3-4 eggs. I gave it to him. And when I had found this chance, then I went to ask that manager. He took me to his laboratory in the quarry itself because they were trying to taste those.
Clean the cement.
Cement? No, they were trying to taste limestone grade.
Okay.
So he took me to the laboratory and they were some spherical objects which I had collected. I said that...
Oh, they already had those?
They had already. See, that is just labor. Sometimes they use it for measuring weights and all. But we really don't know. Because as and when these things are blasted up and the spherical picked up and they are just dumped like that. So it was very difficult. I said these things I really don't know, but they are very important because they are coming in. So they are all from that only. So then it was this in the month of 81, December, January. I closed my camp, I sent the specimens, and then I was not a paleontology. From Gujarat office, my director sent it for identification to paleontology laboratory, which existed division to Jaipur. Oh. And in between, what had happened, between December, January, still I closed my camp in May and went back to Ahmedabad. There was also one of my colleagues, Gajendra Nath Dwivedi, GN Dwivedi. He was also mapping with me. But we had adjoining areas. So he had also found something. But he found something which were like a bones, not eggs.
Okay.
And he was telling, sir, they look like a plants and things like that. So then, but I had not seen, I had not visited that each spot and they were like that. So when I went back and his fellow also came and he said that these are the things, Mohabey and things like that. So, but some of these bones, they were exactly like a typical bones which you get and it. They were big and that. I said typical bones. But that time, Dwivedi, he was a typical Pandit type of fellow. Okay. And he will not like to work on
these things.
This reluctant. He was even reluctant to
he didn't want to touch bones.
When I take bones and these are things like that. So that time, Shubhankar, when I went back and asked my director, sir, what happened? Is any report come? So my director called me, come, go and see what has come from there. So there was this tinker from there to me, from the paleontologist from Jaipur. He said that a geologist who has collected Mohabey, he should be aware what he is trying to describe. He cannot go and describe anything like a dinosaurs, eggs and like. To us, they are simply clay balls. In no way they are fossils.
He said that?
He said that, paleontology. And it was a stricture. My director said that if you are not sure about it, why do you send the specimens and ask for investigation? At least to a certain extent it should be. I said that no, so these are the doubts. These are the two. And if it is to be confirmed, I have to send it to experts.
How else?
How else I will? I have not worked on it. So then my director said, no, it does come from them. So at least at this stage, I will not take it as dinosaur. Though in my diaries, which we sent from the report. I had mentioned it. Either they are dinosaur eggs or they are maybe some fruits. Then I came back. I was very upset because it was a stricture to me. And then I went on saying no one had seen dinosaur egg. Report ही नहीं हुए थे. India में. Everyone has seen. No one really looked how to study dinosaur eggs, what to study there in the egg. Then I was trying to look at some of this literature in our library. Somewhere I came across two references. One was by Horner, if you have heard of John Horner. He was the first who reported Myasauria nest from Montana.
Okay.
He has one article in 1979 paper published in Nature, where he has talked of dinosaur nest, but they were different types. Elpitiga, Myosaurus, theropods and ornithopod dinosaurs. And there he has described those things. And there was another paper by a German fellow, Irban. He has also some abstract somewhere. And there in the abstract, there was a small address. And then I said that how to study, I am not able to get it. But there was some monthly clue came from Horner.
So you contacted them?
I contacted them even. And that time there was no telex, no email, nothing. So when I sent a mail later to him, that was Indian letter. That Indian foreign letter it used to come, that big one. I just put some drawing. And what I had done very crudely, I came when Kennebec, I started cut some eggs and I was just trying to look as a study some pathological section of rocks. And there I was able to get some structure. I was not trying pattern in the eggshells, which I was doing, which was occurring. I sent it to Irban. I said that...
the German guy.
That German guy. It took almost 3 to 4 months. It will go by ship and come back. By that time, he had sent me a letter. He said that you are given a preliminary description and the sketches which he gave. To me, possibly they could be egg, but I cannot confirm it as such. Unless you send me some photographs if you have taken. Because my drawing and things like that. But then it so happened, Shubhankar, when within a fortnight, I received a big parcel from him, where he had sent all his literature, most of them in German, but at least the abstract and all
were in English.
They were in English. And then there are beautiful drawings, illustration, and almost how you study. And meanwhile, I had also prepared. Then I went on looking at, trying to
so you taught yourself how to identify.
And then I said some of my specimens and the fossils, they are much better than what Irban has described. They are certainly fossil eggs. I don't know which type of dinosaur bones they are, because it's difficult. Even if I get an egg, to assign it to which type of dinosaur it is.
You need to know so much paleontology.
But then this was there, and then it was in the year 1983. It took almost 1.5 years for me. Because current science will also take some time. It is 6 months to publish any article. To accept that. And then I published a note in that. And then it was also a problem because a very recognized, stalwart, internationally acclaimed Indian scientist, he came across that Mohabey, he has found something like and these things that it's a dinosaur eggs. So there was some seminar in physical research laboratory. So all along we went to that Lothal for that excursion. And he said that I would like to see it. I said that you are most welcome, but I need a permission from my director to show in his specimens. But he insisted, and then I phoned, and then my director told, all right, show it is very renowned one. And then he asked me whether you would like to give me a small piece of that. I said that it is too much, sir. But nevertheless, you are such a recognized person.
Yes, I will.
Then I again phoned him. My director said, this is time for you to go back because I am already back too. It was 6:30, 7 o'clock. But they said he is asking for a small piece, sir. What is there? He said that all right, give it. And that fellow really played smart with me. Because I had taken all the efforts, I had proved that. And he has taken that specimen, and then without interacting or communicating with me, he communicated with my head director general. And he said to him, that director general, you are a young entrepreneur geologist, he has collected some ball-like objects which I identified as a dinosaur.
I have identified. He has identified.
He has identified. So immediately Director General sent me that letter.
Uh,
And then see what is this you see. Then my director was Ramkrishnan. Sir, there is a history where this fellow, it has taken a long effort.
right.
More than 1 year now he says that.
He is claimed.
He has claimed.
God.
Then he said that you have to publish and print it immediately. So that but next assignment they immediately gave it to me. Then I was put, and then I was hunting for the dinosaur eggs and nests, and I found dozens of those nest sites in the same Kheda belt, and then different of nest sites and different types of eggs. And then from that I was able to show when I visited. This is not the nest sites or the nest, they were different multiple animals.
Mixed,
multiple animals, same type of animals, but they were many. They were living in community. Because one nest, other nest, किसी में 10 अंडे, किसी में 12 अंडे, किसी में 18 अंडे, but they were of similar size. So I said,
so they were a herd animal.
There was a herd of animals, same type of animals which laid the eggs.
And you identified it as a Titanosaurus or a sauropod?
It was later on, because in some of the papers which I got from Urban and all, they from France, he has described some megalolithid eggs as such. And there he describes something. So I said that if it is there, these are the sauropods. We have only Titanosaurs known from India. So possibly it can be Titanosaurus. But Dinosaurus, Titanosaurus, maybe there are different.
Multiple.
So I really don't know. And unless you find some sort of a embryonic remains or hatchling, it's very difficult.
But India has identified only 2 Titanosauruses, right? Genosaurus and Ichthyosaurus.
Actually, basically, you can say 2, Genosaurus and Iasasaurus.
Yes.
One is from Pisdura, Dongargaon, and other is from, earlier it was Indicus substantively, but later on Jeff had revised it to your Iasasaurus.
Okay.
So these are the 2. But there are many others which were established by Matley.
Okay.
Leplatosaurus, Indicus.
But they are not, they are invalid now.
Those species are invalid. As I said, that they said that there is no Titanosaurus genus that existed in India. They are Titanosaurs. Titanosaur family you can say, but they are not the genus.
Okay.
The lower classification.
Okay.
So within that, we had till now only 2, as you says, the species sauropods. Titanosaurus recognized. One is Iasasaurus and Dinosaur. Jabalpur and that. But there are many others. Earlier they say Leplatosaurus, Titanosaurus blandfordi. They definitely do not belong to this Genosaurus or Iasasaurus. So still holds a different taxon other than these 2.
Okay.
But whether they may not be Titanosaurus, but they are certainly Titanosaurid. They belong to broad family.
Okay. So if they just belong to a broader classification of Titanosaur.
That's why when we say Titanosaurs or Titanosaurid, but the moment you come to genus, you come to that particular.
मतलब taxonomy का ही issue है, otherwise Titanosaurs ही है वो.
Titanosaurs ही.
Okay.
So then gradually we got, and then I started publishing in this nest sites. They belong to a herd of dinosaurs that shows this Titanosaur in particular, Titanosaur which laid the eggs. They were living in communities. And usme there was beautiful when I started studying the nest. They were saucer shaped.
Yes.
And all those nests in all the different that time I am telling you maybe around 8 to 10,000 eggs. We have eggs in different nest sites, 20, 30 nest sites which I have found all over in that region. And there all those eggs invariably they were occurring within these sandstones only. Sandstones everywhere. So then I thought that this why it's invariably they are occurring in the rocks which were previously sand. Later on it's lithified to sandstones.
Okay.
Because that time when the environment was there and those sands were riverine sands.
Right.
Later on it lithified.
So sand turned into sandstone.
Sandstone. And there are many geological processes, calculation, things like that. So that means these dinosaurs, whosoever laid the eggs, they invariably prefer to lay their eggs in the sands because they were very soft and it was easier for them to bury their eggs. They will duck the ships with their hind limbs,
Right.
what they do today.
A lot of birds also.
But do, and even the reptiles, if you see.
Yeah.
Even your turtles.
I mean, recently we are seeing it on the beaches.
Beaches, those turtles, they
Lakhs
bury
of
it with
turtles are
leg.
coming.
So they generally use their hind limbs.
Hmm.
They throw it
Ah.
and to it they get buried. Even from the crocodiles, they try to make some sort of a mound building structure
Right.
with mud and some
Right.
vegetables.
So there is no mud, there is no plantation,
No,
nothing.
nothing. Because when every nest which I was trying to plot and see, and each nest site belonged to, though they were spherical, but when I tried to study the microstructure, the size, they were different. So it showed me that basically it belongs to different types of dinosaurs, but each size belongs to an individual community. And then that showed me that basically these dinosaurs, they buried their eggs in the soft sand of the rivers.
So on the river banks of Narmada
Or that time they are in Kheda area. We are far away from Narmada.
right.
But that time many riverine channels existed there.
Right.
Because everywhere
Ancient river channels.
Ancient rivers. Because Narmada, it is very active since long.
Right.
That's why we Narmada. But though it was Rajasas Narmadensis, but it has nothing to do with
Narmada. Achha, I thought
you are far away from that.
Okay.
Because these basins are
Okay. And then, sir, what about the mixed hatcheries and graveyards?
Mixed hatcheries you don't get, because that particular site at Triassic, it's unique in the sense that it is the only locality in the world where you get hatcheries, nest sites of dinosaurs. It's not only the one nest sites of sauropod, but in India there is also
A
theropod sites.
Mixed?
No, there are two different sites.
Okay.
In the same locality.
But
they may be separated by 200 kilometers,
right.
but at the same time plane.
So a carnivore and a
Herbivore dinosaurs. They
were living together.
So probably this group of predators,
Right.
they were trying to live upon, and
Right.
when there was an opportunity, they will bump
So
on
these
that.
predators were following their food
Exactly.
wherever it went.
Because they were the potential
Right.
prey for them. No?
Right.
So they were following. And at the same site, then you get a mixed up fossils of theropods and sauropods.
Right.
It's a slightly different horizons than the egg-laying horizons,
Okay.
where these animals died and they were brought by rivers
Okay.
with full of energy, floodings and
Ah.
those buried. So that's what I use the word. These are the graveyards of bones, and they, at the same time you get the hatcheries. But it is the only single locality. Otherwise, you don't go dinosaur bones so many.
Right. And
that-
these different these graveyards, there are different species of
yes.
sauropods and theropods.
Yes, as you see, if you say of Rhyoli or Kheda, particularly this Rhyoli. In Rhyoli area, so far there are two types of abelisaurids we call theropods.
Okay.
It's a abelisaurs. Like Titanos, there was a abelisaur group of theropods, bipedal carnivores. So there are two described theropods. One is, as you said, Rajasaurus narmadensis, and other is Rhyolisaurus gujaratensis.
Okay.
So there are two different. But other than that, we have sauropods. Titanosaurus is there. They also try to discover Antarctosaurus from there. So we have some four species, two species of theropods and maybe two species of sauropods from that particular site. And I had also another smaller eggs, very small, almost of the size of the chicken eggs, which are there. Because that time also...
So they must have been small mammals, reptiles.
Reptiles. Because here just now in 2024 itself, I described a very small theropod dinosaur. Maybe of the size of a
dog,
sheep or dog.
Oh.
From Pisdwara area, Dentary and all. That published in the Journal of Vertebrate Paleontology, US. That is also with Jeff.
Okay. So very tiny.
Very tiny. And this tiny theropod, they are also reported mainly from Jabalpur.
So this could be like a velociraptor.
Yeah. Small one. Yes. This small one. So we call it large-bodied theropods and small-bodied theropod. Because sometimes the large-bodied theropod, you may get a very young juvenile.
And these small... okay, so you could be confused with a juvenile.
With that. But then they will have different structure. The teeth will be structured. Skeletal will be different.
Okay.
The femurs will be different.
Okay.
So that you can identify. Even the caudal vertebra which we get, it will be different.
And these smaller ones, they are more likely to have feathers.
No. So far we could not get anything on that.
So far, we have not found any feathers in India.
No feathers. For that matter, we have not found any fossils of any birds in India, either from the Gondwanans.
And birds, and not even pterosaurs?
Pterosaurs also we don't get.
Pterosaurs
Though they tried to report it from some southern provinces, but it was all.
It was not
no
proven.
confirmed. Yeah.
Oh.
So
But why is
not
that?
pterosaur?
Because pterosaurs are late Cretaceous, right?
Late Cretaceous. They also existed in older times. Also, they are known from the earliest Jurassics also. Pterosaurs. So these pterosaurs, what we call it, is a flying reptiles. They are different than the bird.
Like they are bats.
Like bats, exactly. So whatever you get, there's some sort of a leathery wings like that. Not exactly the feathers what you get.
Yes.
But that is intriguing. Why in India we don't get pterosaurs, or for that matter even birds for that matter.
And sir, what were the mammals like that time?
That time, what way mammals we are getting, and what is
they're very small.
Very small, almost of the rat size, shrew size.
So the biggest mammal was a rat-sized mammal.
Yes, exactly. They have been reported what we call is Gonanatherium, Sudamasarid. They are reported mostly from there is one locality in Naskal, that is in Telangana district, Telangana state, in the Rangareddy district. Even GVR Prasad from Delhi University and G.P. Wilson, he's Jeff's brother, he is in Seattle. He also works a lot in geological survey of Anantaraman. They found many of the small mammals described from those sections. And very recently, I think I have found teeth of these mammals also.
You also found?
Which I am trying to work out.
So it could be a new mammal.
It could be new mammal because I never worked on mammals. But that stage I am trying to.
And then sir, maybe if you could shed a little light on after the mass extinction happens.
Yeah.
We have the mammals now growing.
Exactly.
So now they have replaced the food chain or the top of the food chain, and they turn into what is known as megafauna.
Yeah, exactly.
So could you shed a little light on what was the megafauna like in India?
Megafauna like India, it was, as I told you, it was dominated by mammals only.
Right, so they had to be mammals, but they were bigger mammals.
Big mammals. Some of them, they're very giant. Even if you go back into the history now where we call it a quaternary sediments. Maybe say around
30-40 million.
No, much younger. And even from where the history of the mankind starts, because you have the Narmadensis, Homo erectus, that's discovered by Sonekia from Narmada, Hathnora and all that. Homo erectus, this is the oldest.
So that is about 2.5 lakh.
That is 500,000. 0.5 million.
50 lakh years.
So we found it. So along with that, we get many mammals as well.
Right.
Fossils of
so these mammals existed along with the cavemen.
Caveman, yes, Homo erectus. Because we have Homo habilis, Homo erectus, and then we come Homo sapien. That's what we get. So we get the oldest, that's why it becomes very important. 500,000 is discovery. But then we had big mammals there. And if you go to steel, that because that time we had an ice age and things started coming like that. So there was a gigantism of mammals. Megafauna that occurred there. So it is not in India, it is everywhere. And if you look in the Meghalaya, they have identified one section. That is not, I'm telling you, that will be 140,000 years old. They are called in Himalaya, where they are identified at that stage where that warming event was there. That was everywhere, not one in India.
So after the Ice Age?
It was a global event.
Right, global warming.
Global warming, and they recorded it. was a desert-like condition everywhere on the globe. So that is recorded there. So you have mammals, Paleocene mammal, after this extinction at Cretaceous tertiary boundary or so-called Cretaceous Paleogene boundary, when you have a mammals, the earliest Paleocene mammals, they were very small sized. As they evolved from 64 million years till today.
Right. Now they are the biggest.
So they were evolving for the last 55 or 56 million years. So they also attended gigantism, and then they dropped out because there was the event. If you really go to this, what they describe from Narmada as a Stegodon, Ganesha, and Narmadensis, from these horizons, they are really giant size.
They
Even
look
in
like
the
bears or rats, or what could be a
Even
comparison?
if you go to Geological Survey of India, Museum Aerians Intelligence, you will find a bison's, skull of the bison's, that will span more than 2 meters. We thought they were subgigantism. If you look at the tusk of the stegosaurus or elephant, they were different. Mammoths. Mammoths were mostly, they were woolly. They had hairs and all.
Right.
But
woolly mammoths.
Woolly mammoths. So here, but you get stegodon and things like that. Big elephant.
Even the Indian elephant.
Indian elephants. So there, they had also attained some sort of a gigantism there during that particular.
So those elephants were bigger than the Indian elephant today.
Yes, definitely much bigger.
And then there were some mammals that went into the water.
Some
mammals that must have gone into the water.
Yeah, because they were there. Your whales, they are mammals.
Exactly.
They were there.
There was some information that whales could have come from the Indian peninsula.
That is possible. They're still going on because they have recorded whales from the much older Miocene. I was telling you, Shivalik fossils and all.
Right.
From Kutch also they have recorded cetaceans, mammals, these things. Almost what they call it is sea cows and all. So their origin, because in Pakistan also, because earlier we were discussing about the India,
Right.
India, that
included Pakistan.
That included Pakistan. We had also dinosaurs which was living there.
Right.
Pakistan, Balochistan and all.
Right.
And then if you look at those dinosaurs there, they are almost similar to what we get. Because it's at the same continent.
Of course, had to be.
Had to be. So it's very, very interesting there. So you cannot isolate the dinosaur fauna of Pakistan from the India, because they were one for.
Of course,
there were no barriers there. But the problem is that when we talk about this Paleocene and Cretaceous or Maastrichtian, when we say Cretaceous tertiary boundary, the last stage of Cretaceous and Maastrichtian, and the earliest stage of Paleocene is Danian. So that Danian mass Cretaceous, as you say, global mass extinction, by which served out more than 70% of the life that existed both in the sea, in water, and the land also. Both of them, they disappeared. But the thing is that in India...
But then some of them survived, right?
Some of them survived. So
how did they survive?
Because most of them, they were aquatic.
But you said that the aquatic also disappeared.
Disappeared. Like your ichthyosaur, mosasaurs, they became extinct.
Because mosasaurs had to come up to breathe.
Yeah. Because they were aquatic. Because their structure was like that.
Right.
Because the nasal end are from they are positioned in such a way that from the time to time they had to come out. Your dolphins, which are
Gangetic dolphins.
They are all mammals only.
Right.
So they were mammals. There were many things. And the thing is that when we talk of a Cretaceous tertiary boundary or Maastrichtian, where we delineate, so most of the 70%, and whatever sections, when you try to really define a Cretaceous tertiary boundary where the global mass extinction happened, and it is global.
Right.
So you have to be very precise. When as a geologist or paleontologist, I go to the sections, I must see a continuous sections across this extinction level. What are the animals and plants which were living before this extinction level,
and
what after that?
Right.
How many of them they become extinct? How many of them became survived, or they adopted new forms? So these continuous sections, which we are none in India, and all over the world, when they are trying to research the Cretaceous tertiary boundary sections, 99% of their sections, they are marine, whether they get continuity of that.
Okay.
Whether you Gubbio, where they find this iridium layer, that was Alvarez and those fellows, based on this iridium concentration, they speculated with this iridium concentration, that anomaly, it cannot be attributed by our terrestrial.
So you're saying that we need some sorts of marine paleontologists to go under the ocean and...
No, it's very difficult, because you see, in marine, if you say, in the marine you need to see the complete section which is exposed. As a section, as a field geologist, when you go there.
But there is none.
There is none. You may get them, we say oil and natural gas corporation, when they are drilling through the cores and all, if you get, then they try to come on.
They could extract some
Yeah,
cross section.
No, they have to cause, even in the Bombay offshore. Some of the cores they got it continuously because these sediments in marine conditions or oceans, they will try to continuous. There are no gaps or
because scientists have been doing it in the permafrost.
Permafrost, yeah, they will be doing it. A lot of drilling is going on in Antarctica.
Yes.
But the thing is that it is the continuity of the sediments. But as I said, most of them, whether it's a Gubbio, where they found this iridium,
Mongolia,
Gubbio is Italy. Gubbio section, and then we have Stevens case, your Denmark, and then we have Tunisia, Elkip sections, we have Nizo, Israel. Like that, there are many sections. Cretaceous tertiary boundary where they are sure about this.
That they know for sure कि ये था और ये नहीं रहा.
But I as a geologist, it's very difficult for me to believe because they are all geochemical boundary which you are trying to define based on the presence of some geochemical anomaly, iridium and things like that. But as if I have to define a geological boundary, that will be the paleontological boundary. I must be able to point out where my vertebrates and where my flora is disappearing. This is the precise level. That can be transitional, where these forms they don't appear, or some new forms appear, or this disappear. Because you see, this extinction is very common. If you look into the history of the Earth, you will get many extinction events because whatever life or organism or animals they exist
has adapted to a certain climate.
So that is Darwin's and all, they will with the new environment adaptation. So the ancient forms, it disappears, resulting in the appearance of the new forms.
Right.
So this will disappear, continue, and this new form which will appear and for which I get a fossil, it will give me the characters of the ancestor fossils from which it originated, and also the characters of the fossils which are descendant into.
Right.
So those characters we basically, but in India when we are trying to work out this Cretaceous boundary, we get Deccan volcanism 60 as you may be getting 69 to 62.
3-4 millions before the event.
But then we are getting the complete volcanic sequences, 700 meters, 1100 meters. We get sedimentary layers which are gendered, and it is a process of the climates and the flora and the fauna which existed during that time. In the Paleohistory, which the sedimentary beds interlaid with the volcanic rock. The thing is that they are interrupted. You are not getting continuously. I may have a younger lava pile. It may be 65, 66 years. Then I have a little older pile, but there is no continuity. I know that particular part it straddles the Cretaceous tertiary boundary, which is defined at 66.02 million years now. So my sections is, I know, but then I am not physically able to.
Like we discussed earlier, that we don't know what happened in the middle.
What happened to that? Because they are
a big part of is the lower Cretaceous, upper Jurassic period.
Exactly. But and when we were trying to see how our dinosaurs with that senior extinction demand, when we were trying to work out, because we worked out dinosaurs, late Cretaceous dinosaurs, all in different provinces, whether it's Gujarat, Kheda, or it was Jabalpur, Chhindwara, or to the south. Then we found, and there was one Professor Hansen, he was from Denmark University. We had also collaboration. I was also there with them in Copenhagen with him. He was the person who was working on orbital cycles and things like that, and isotopes and many of the things. And there, that time, we studied, as I told you, just before the first lava flows which came on the Indian continent, and they came in different times in different provinces.
So first in
Gujarat and like that.
Yes.
So it went on. Then we were able to find out in different provinces. When we studied, along with the available stratigraphy, some magnetostratigraphy or some age dating and different, we found our last dinosaurs, they never reached to the Cretaceous tertiary boundary. They become extinct much before that. And from the first level, which the late Cretaceous dinosaur appear, to this, there is a gradual extinction.
As the volcanoes were bursting around.
Cooling around, and then the changes also.
Yes.
So there is a difference. The first dinosaurs which appears in late Cretaceous, not Gondwana, that appears almost at 500 million years before the Cretaceous Paleogene boundary. And the last dinosaurs, that disappears is 350,000 years. So they have nothing to do with the Cretaceous.
The mass extinction.
So if it has nothing to do with that Cretaceous tertiary boundary, they have anything to do with the extraterrestrial impact.
Right.
That global meteorite. Because this impact, which they conceive that it is to be of such a large size, it is 10 kilometer size asteroid.
Yes.
That will hit, which they conceive that it has Chicxulub, Mexico, New Mexico, where they hit it, and it will create that 100 kilometer diameter. Yeah. But when they dated that Mexican crater, the age of the Cretaceous Paleogene boundary and the age of the crater impact, there is a difference of at least 200 to 3,000 years. So we know there are speculations. But so at least in India, and we have no undoubted extraterrestrial signatures. We are not able to get in soil. We are not able to get iridium, or we are not getting any serendis sporules, or we are not getting any chalk cores which were considered because of the extraterrestrial impact.
Okay, so you're saying that whatever must have happened, the stuff must have flown into the sky and landed as
yes
in other places all over the world.
No, because the thing is that even if it's a extraterrestrial impact,
right,
or if it is a volcanic eruptions,
right,
both of them will result in the same sort of mechanism. Because say if the volcanic is coming, so there will be huge ashes
flying
into
the orbit,
that debris. And then you have a lot of those green gases and toxic gases. It can cover ashes. If you see, if recent Iceland and all where you get this, they completely cover, and there are mud flows and ash flows.
I heard somebody say that after the event happened, there was a complete or almost a blackout for almost 20 years.
Exactly. Because the thing is that, Shumankar, because if you conceive extraterrestrial impact, we don't deny that it was not there. But we said that Indian dinosaur has nothing to do with that. But then, because in Europe and America, which people very strongly believe that global mass extinction is mostly a culprit is extraterrestrial impact. And that for impact, they have considered the Chicxulub as an ideal example. When this 10 kilometers diameter asteroid hits, it gets buried, the temperature will be hundreds of thousand degrees. And when it is coming down, and it is entering the atmosphere, so to troposphere to stratosphere to the lower level, it will generate some sort of a vacuum. It is all warm up. It will generate a cone. And it is a cone. It will all be low pressure. Where anything it impacts, it's not only the ejecta and debris from the asteroid, that 10 kilometers, but also the land where it is impacting. And everything will rush into that cone, which will be taken up to that. You was in the Japanese, Hiroshima and how this cauliflower like cloud. Because it has generated that heat. Yes. And then it is taken to troposphere and stratosphere, where there is a global, your earth is moving around. And basically these dust clouds, it envelops the whole earth.
And by that time, it has triggered a lot of earthquakes, tsunamis.
Yes, definitely, because it was an impact. So they get evidence. Even in Chicxulub, they talk of tsunamis and all. And then basically there will be many the effects of that. Say the dust clouds and cool climates and acid rains. So all photosynthesis. Your flora will be the first to get affected, gone. And as I tell you, animals like dinosaurs, they were cold-blooded.
Yeah.
So they will be very sensitive to any temperature.
Right.
Endothermic means sometimes they will able to sustain themselves. Like your small mammals, they are okay. We can try to maintain.
The amphibians are fine.
Yeah. Otherwise, it's very difficult. So many of these things, and if the volcanoes, they are going up, the first impact of the volcanoes, they will, as well speak, they will be migrating away. Anything.
They will try to run away.
It's a natural. They will try to run away from that source. And they try to go to the... Then, but subsequently, because the food chain is also affected. There is a photosynthesis, your photosynthesis is affected, the flora. The food is not that much. Complete food chain is affected. So naturally, their prey plants are not available, herbivores affecting predators. Some are dinosaurs, depending, they will be more susceptible to all these ills and how they respond to the changing scenario, changing temperature, acid rains out. So that's cumulatively. But then we found that's what we said, that in Indian subcontinent, we look at that.
They never even faced all that.
Faced that catastrophe of global impact.
They were gone.
Because we are far away. And it's not only the animals, dinosaurs, also the plants. Our plants, because we were trying to, because there was Dr. Samant in Department of Geology, she was exclusively working on plants. Flora, pollen spores and this. And then there also we found the dinosaurs and the plants. They were responding equally at the same time. Advent of Deccan volcanism, then the flora starts getting changed. Just before the volcanism started, our flora was dominated by
trees,
angiosperms and gymnosperms flora.
Right.
And you talked about the flowering plants and seeds. That appeared much later.
Right.
That appeared sometimes in the upper Cretaceous or late Cretaceous. In Indian subcontinent, we find that the first dinosaurs and the appearance of the angiosperm, your flowering plants, which you were inquiring, they appear at the same level. And both of them, they were affected by the first arrival of the first volcanic activity.
Right.
The flora changes from angiosperm, gymnosperm dominated to angiosperm pteridophyte germinaceous after the volcanism.
Right.
So we are.
So these fruits and flowers appeared after the volcanic eruptions.
No, they appeared during the Lamy times because dinosaurs were also there.
They were eating fruits.
They were eating fruits because we also got not only the eggs, we got a lot of coprolites. These coprolites also the unique evidence.
So coprolites is the dung.
Dung. As morning you were telling coming from the horse's mouth.
Yes.
We can make many speculations what dinosaurs were eating. They need a lot of plants to eat and things like that. But if you have to reconstruct what type of plants really existed that time, we are different, but they don't eat everything which is available. Right. Even if you go to today's condition, jungles, there are giraffe, they prefer something, camel, they eat some preferred diet. Even your sheep, cows, they have a preferred. Grasses, grass they will eat. So they have a specific plant which they prefer to eat. So what type of plant they were eating? So this
and those plants don't exist now.
Some of them, say I will tell you, I will come back to rice. That rice family, when we were working, Caroline Stomberg was there. We were able to come across the presence of rice phytoliths in the coprolites that showed that rice family existed that time.
Okay.
So they were not much. So that time the flora existed, but what type of habitat they were eating, it became very important for us. 1939, Charles Matley, he reported dinosaur coprolites or fecal mass or the dung mass from Pisdura. And he tried to describe 4 types of coprolites based on the morphology.
So only type A is dinosaur.
Type A, he described type A, type B, type BA and C. So type A was typical sauropod because they were very big. Up to 10 centimeters, you state beautifully segmentation and things like that. But it was always doubted because even the Cherenkine in America, they said that because that time it was based on the presence of what type of reptiles they will defecate and what type of they will give such a large size of dung mass. So only contemporary animals were dinosaurs. Though in this area we have crocodiles and lot many turtles living together. But producing a fecal mass of that size
is not possible.
It's possible. It has to be big size.
Has to be
only the sauropods. So based on that, Matley speculated that this can be sauropods. Others we get some spores, we get a rib type and things like that. So it was always a speculation. Those sauropods, but because we are not getting anything inside as a content in the coprolites, no plants, how you can say that they are coprolitics of coprolites. But in 2000, I got a big catch of coprolites.
Okay.
In Pisdura area also. Okay. In one of the field in that area. And there I found that all these coprolites, I'm telling you, every second or third coprolites which I was trying to break in the field, it has a plant tissues inside. Everything. So that shows me, oh, these are herbivores. And then when I tried to study and prepare polished session, thick session, and then they showed me presence of this angiosperm, flowers were there, inside these small sphex were there.
Do we also know that there were some omnivores as well?
Omnivores, some of the sauropod dinosaurs, they were reported. Even they said that even the sauropods of Titanosaur, like in Argentina, they were able to find in some of the coprolites some fishes like that.
Okay.
But we really don't know whether they ingested those small
by
fishes, mistake, or they can thrive it. But then it is very interesting that in one of the specimens, I got a turtle, which to me looked like a regurgitate.
Okay, like
it must have swallowed it and it came out.
Okay, so that turtle was spewed out.
It was just small, because here if you go to Dongarga, are beautiful turtles. Wow. Small size, big sized. And sometimes you get of such it looks like a family if they were living together. Oh, wow. So they were very small.
So you can build these small stories
on that. So probably that fellow
must have been eaten by some dinosaur.
Dinosaur. And you were just telling about even the rice, like that we got in this coprolite mass. So at that time the grasses, there was always a problem whether the grasses really existed.
Right.
So there was always an enigma. And the people, they did not. Grasses, they said that no, they are C4 type of plant. Dinosaurs were never.
Yeah, like a T-Rex would have never seen grass.
Grasses, or even the sauropod, Titanosaurs and that. But then we found phytoliths of grasses. It's a grass family. Poaceae, Ornithischians was say. And then it was, we did a DNA molecule dating of that. And when you do a DNA molecule dating now, it takes you back when that particular species of a rice, at what time it must have originated. So it takes you back. These sediments may be 67, 70 million years back. But molecular dating.
But the rice would have been even older.
So it is because we published that paper in Nature. It takes back to 140, 150 million years. And there we said that the rice family, it never originated in China. India has that type of origin.
Wow.
So these are some of the things. But these copper-like things which came, that it provided the first evidence is, we said, that what this particular fellow, he ate, what type of plants, it is there. In none of the coprolite Shubhankar, we got any woody tissues. Hard woody tissues like palms and all. Because these woody tissues are palms and they will be never be rich in proteins and other carbohydrates, for which they will, this herbivores with these animals. But these angiosperms, your flowers, seeds, they will give all sides. So they are very enriched in that. So they were trying to consume, and if you look at the skull of these Titanosaurus sauropods now, at least Indian, they have a very weak dentition, like a peg-like. This is the upper, this is the lower, it will like that. It's widely separated.
Okay.
Peg-like.
Okay. So they are not sharp teeth.
They are not sharp teeth, and there is no mechanism for grinding. If you look at the other ornithopod,
like cows will grind.
They will grind and munch. We get in other ornithopod dinosaur, Triassic, so they have batteries of teeth. We have the grinding surface.
So they were swallowing everything that they were.
They were not, because their jaw mechanism is very weak.
Right.
So simply they were just crush it and take it. And that's why whatever we get inside the coprolites, they are simply comminuted plant tissues, break-up plants. It's slightly grinded, and that's why we are able to get the complete head-on tissues, the pollens, the
because they were just eating and
it was going on. They were not munching it. And then you can just imagine a dinosaur. If I go for a say Titanosaurs that must have existed in Jabalpur, like Iosaurus in Dongargaon or Jabalpur, whatever it is, dinosaurs. If I roughly take its length at 30 meters. Or even more than that. You can just imagine. It's eating, it has to come up to the tail. It has to travel that 30 meters. How much time it has kept that food.
Right.
That ingestion, its fermentation, and how much time it will take to defecate it. So that all goes with that. So we try to study those aspects, but this Pisdura is a wonderful locality in the world which has given the undoubted evidence of what was the preferred diet of this sauropod
This
dinosaur.
is near Jabalpur, right?
No, this is Pisdura, Chandrapur.
Chandrapur.
It's hardly 110 kilometers.
Oh, wow.
It's in a Varora district.
Achha.
Varora Taluka of Chandrapur district.
I'd love to go sometime.
So by this Ayasaurus, if you take it to Varora, we have a Dongargaon and we have Pisdura. Both the localities hardly 15-20 kilometers.
Sir, I think we can go on forever.
No problem. Exactly.
I wanted to ask you the story, and then Sanajeh Indicus. This is something that I really wanted to talk to you about. Talk to me about the relevance and importance of the specimen, and then how you found it.
Okay. It was in the year 1986. When I had a project for locating dinosaur nest sciences 6. During that 1986, I came across one of the nest sites near the village Dhuri Dungri.
This is in Gujarat.
This is in Gujarat, where I found a nest site which was full of dinosaur nests. At least 20, maybe 24, 25 nests were there, and maybe around hundreds of eggs were there. And when I was trying to study, as I told you, we plot the eggs, how the individual nest, how the disposition of eggs are there, how the eggs are laced, what type of shape will have that. So in that course, I found evidence of some dinosaur small bones were there. And then so I said that some bones are, because whatever nest sites we had found till that time, we had never any bones found in the nest sites of dinosaurs.
Right.
So it was difficult in the sense that
why are there bones next to
we get only dinosaur. So then here it poetic. So then we started searching more meticulously there in detail, and in one of the nests, I saw those nests along with the eggs. There was the area of the dinosaur bones, articulated dinosaur bones, which were there, fossilized along with the dinosaur eggs in the dinosaur nest itself.
Right. And one egg was hatched?
Yes. I studied little later.
Okay. You didn't realize it at the time?
Because that time it was very important for me why this particular fellow is lying there. So in one of the blocks there, in that nest, I found some limbs of dinosaur bones. I thought it looks like a small dinosaur hatchling which must
have died next to it.
Because it can get buried and all that. So I was trying to study, and then it was very difficult because it was such a hard calcitite sandstones. And then I studied, disposed all those bones and eggs.
So when you say that you were trying to study, it means that you were chiseling away or you were grinding. What kind of tools do you use?
No, when we go to field and collect it, generally I avoid excavating this dinosaur nest.
Okay.
Because I don't want to interfere with that. Because there may be hundreds of eggs. But once I have a study of those field setting, I have already data. Occurrence of the dinosaur eggs and nests and their pattern, that gives me basic data how these dinosaurs, where they are laying, how they were manipulating the eggs, what patterns, and so it tells me basically about the nesting behavior of these dinosaurs.
Okay.
Because they were not even no vegetable material. So what sort of, if the dinosaurs, they were buried with the sand which they have bugged out and they are covered it. So naturally the incubation will be because of the sun's energy.
Right.
We don't know how many days it takes for the incubation of all those data which collect from the field, and then I collect hardly some eggshell fragments or 1 or 2 eggs. For morphological study, I will avoid always distracting. And that was the instruction to us from the Geologic Survey of India, not to destroy the natural occurrence of this fossil. Let it be like that. So we don't know because it is occurring like that.
But
they occur in the position.
But wouldn't sometimes opening it up or
we did that. It is where it is actually needed. You said the importance of this nest site. You are getting those disposition of eggs and nests as they were laid 70 years back. So you just imagine.
That itself is a very
Exactly.
valuable
Very
thing.
valuable. You are seeing in a context to the complete nest site where they.
So you take some samples out and leave the rest of it as a scene.
But there can be some nest site if you have to really study. Then only very quickly we try to remove one particular nest only, so that we can study. If we have to scan the entire nests there. So these particular snakes. This snake fossil I identified later. Bones were there.
Years later.
Yeah. So when I found limbs were there, the vertebrae were there. And then, so I thought that it is better to excavate this. So I didn't remove the complete nest where it was occurring. I removed a total block where was a small...
You took out the entire block.
Right. With some eggs there.
Right.
And there was some egg which was surrounded with some vertebrae there, center. And I removed it to Ahmedabad. Ahmedabad, I was finding it very difficult to prepare that specimen. I could not have done it without damaging the specimen. And as I told you, it really needed some very advanced preparation of those techniques. But morphologically, then I studied, I was trying to take measurements. Based on that, I published some paper. There I said that within this. And in course of that, what happened in many other nests, in say other nests in the same nest site, again I was able to find such bones there. So I said that why this is a single nest site which is frequented
with bones
and all. So but when I removed it, took it to then I published a paper in 1987. I described a small hatchling and that specimen was I was transferred to Nagpur, 89. And I went there and I was, this specimen I was trying to do whatever.
So you took the specimen with you?
No, it was there in Gujarat only. I described then I was trying to. And then I was always speculating, trying to interact with the people. Because in some of the papers that came later in 1994, 1997, there are some people, Kenneth Carpenter, Walloms and things like that, Watson, they became very interested when I described this juvenile dinosaur coming from the young age. They tried to reconstruct. And those things also got published. But so far, that block which has contained, it was only getting attention. And a juvenile dinosaur, hatchling of a dinosaur, when it comes out of eggs, that was being focused.
So people were thinking that this was a juvenile dinosaur.
Juvenile dinosaur for that particular block. That particular block was dinosaur only. Till it is dinosaur only. But then remaining those small bones were there. So in that paper, which I had published in 1987, I had mentioned it there. These dinosaur bones, which looks articulated, but somehow they look different. Then the articulation which
so you could see that it was a snake-like
pattern, and then the articulation of one vertebra with the other, because it's a vertebral column. Even if you see, they are articulated. One vertebra, other vertebra, third vertebra, like that. But they were different than what are the other dinosaur typical mega big bones I was getting. So there I had mentioned, picturized them. They look different. They have a zygotine, zygosmin arrangement.
It's not exactly a dinosaur.
But snake, I was not able to see. So that specimen was still there. So I came back to Nagpur. Professor S.L. Jain from Indian Statistical Institute, he said that Mohabey, I plan to visit Ahmedabad and I would like to have a look at your specimen where you try to describe those eggs and juvenile. I said that sir, I am here, but you can verify. He is a professor in picture. I said, all right, anything, I may be wrong. If someone is coming and trying to come out with a better interpretation, it is
Might
always...
as well.
I don't feel shy for that. So then I immediately tried to phone my director, say that S.L. Jain is there, sir, he will be visiting if it is possible. Then my director said, your specimens are there in some other building. Who will dug it out? Say, sir, one of our surveyor was there. I said that he knows it, sir, because he was associated. He knows where all our specimens are kept there. He will be able to make out, tell. And I can tell to, he says that, okay, then I showed Jain sir. Jain sir, he went to that building among the marked things were in a real maze of those specimens.
Like a store.
Like a store, no one was sitting there, I had left. And then he said, Mohabey, he didn't write me, he thanked me. to have a look at. And then in one of his paper, he was a very good fellow, very big expertise on dinosaurs. He simply mentioned in one of his paper, the Mohabey specimens where he shows his juvenile dinosaur there, I see a bones that to me, it give me impression that it could possibly a white snake. Just his first impression.
That was just one sentence.
One sentence, possibly. So when I saw his paper, and then I got it, I was in between he died.
Oh.
So otherwise I really wanted. Jeff Wilson, he came to Nagpur in 2000. There was a big team. Paul Serrano, if you have heard of him, he's a big international worker. He worked exclusively on theropods.
Okay.
Sahara Desert, and things like that. He's the one. Big name. Okay. Ultimate.
Okay. What is the name again?
Paul Serrano.
Paul Serrano.
Paul and Sareno. He is there in University of Chicago.
Okay.
In Chicago, if you go now, because I happened to visit there are two dinosaurs. University of Chicago mein ek hai, and there is a Chicago Field Museum.
Okay.
There are two. Okay. Where you will find a lot of.
Okay.
Or in University of Chicago mein, you will see a lot of those Chinese collection. Small theropods, feather dinosaurs.
Oh.
Original
the impressions of the feathers and everything.
Original specimens.
Right.
Not even plaster cast.
Right.
Because they were working and later on there were a lot many disputes and all. So still you will find. So Paul Serrano, Jeffrey Wilson, and other guy, I am forgetting his name. He was a black guy from that. And one someone from Chandigarh University. They came and they went to Gujarat. And then I was not taken into confidence. I was not even knowing these people are vegetarian. Though I have heard of Jeff Wilson and Paul Serrano. Khosla took him to Pisdura. He took them to Kheda. But he was not able to really that impressive in the field to really show them. And I was stunned when...
He didn't have the expertise to...
Expertise, and he was not really, because he had not seen the section. I will not blame him, but you need a real field focus drive.
Like that passion for
that. Even in the same section, if I visit after 5 years now, I may not be immediately able to locate that.
Right.
So unless you have...
Because the things are so...
Similar. Every outcrop looks like same.
Right.
And vegetation has changed.
Right.
But if you are really worked for a very long, like Riolia, I worked for decades together, I still go and visit. So I didn't know each and every outcrop. I feel like interacting and talking to that
rock.
Each and every outcrop. there. So when they came in 2000, I suddenly received a phone from my gate, JSI. It may be around 1:30 or 2 o'clock. I was about to take my lunch. I was taking a small working lunch. Then that gatekeeper said, someone आपके लिए सब कोई आया है, गेट पे गाड़ी रुकी हुई है, उसमें पूरा ट्रेलर है, तंबू है, और वो लोग अंदर आना चाह रहे हैं. तो मैंने बोला आप हमको क्यों पूछ रहे हैं, आप सिटी में बात कीजिए डायरेक्टर में, उनको अंदर लेना. वो बोले सर आपका नाम लिया है, और वो बोले हमको पैलेंटोलॉजी डिवीजन में. मेरा नाम लिया पैलेंटोलॉजी डिवीजन में है. ताइसेड उनको आप रोकिए और आप उनको गाड़ी को अंदर आने दीजिए और उनको पैलेंटोलॉजी डिवीजन में आप लेके आइए. मैं यही बैठे तो मैं अपने पैलेंटोलॉजी, आई वाज जस्ट at the main door of that my paleontology lab block, and these fellows came and they said that we would like to see collection. I am most welcome. Whatever collection is there, I had a big lab, and then everywhere I just displayed Gujarat collection, Pisdura collection, Jabalpur collection. So they were very excited and see. At that time, you know, I was 2000, आप समझ लीजिए ना, I was in maybe in my late 50s. So when these fellows think, I was trying to impress upon them. This collection, that collection, this is theropod, this is collected, this is looks like a theropod. And then suddenly someone said, yes, Paul, you have seen such things like that. So then I suddenly realized, I didn't realize it, but he's Paul Cyrano. And then suddenly you got it.
Yeah.
My level of confidence.
Because you were like, oh my God, this is the best of the best.
Expertise, and I'm trying to go so much. And then Jeffrey Wilson, then I got.
Oh.
I said, I'm really sorry. I would like to. And then they were just laughing, and they said that no. And then they were there. They said that we are here. I said that no problem. And then they were trying to have a look at all this. Then I said that we are going to stay here tomorrow also. And then we are said that most welcome here. So they came next. I took them immediately because there is some official. No, to my big bosses. Achha. Because there are some official now foreigners.
Right.
You have to also follow those
protocols
and birds. And then my dad said no problem. I said they are experts. And if there is an exchange of ideas and they are able to, will be benefited to a large extent. And as far as I know. So Jeff Wilson, on that particular day, when he says, he didn't comment anything. He was just looking, but he was just trying to get focused on just this specimen only.
Right.
Next day when he came, then he said that, Mohabey, I have a doubt. He was calling me Dhananjay. That time he called me Dhananjay. Dhananjay, I had doubt about this specimen. I think it is the specimen which is something different than what you have described.
Right.
These blocks look to me same. I said that yes, I described this block, but in that paper, he said that yes, but I had some different idea about this skeletons which you have shown. Is it possible for me to study these specimens? I said that you are most free. I will be privileged if you study that specimens. He said that I can preliminarily take photographs and all. I said that most welcome, no problem. But then next day when afternoon we were, then he said that Mohabey, Dhananjay, I want to take these specimens because I am sure that you will never be able to prepare these specimens. Here in India. And almost more than 13-14 years have gone since you gave a preliminary description.
Yes.
So that was my concern also.
Right.
And it was right what he was telling. So there is something hidden which is going to be really sensationalizing. And in the paleontology, I said that, he said that I think it's a snake. And then I need to take this specimen to prepare. I said that I cannot commit, but I will very much like. And then we studied, and then he went back. Then he invited me they were going to Jaipur, where all the collection from Gujarat was kept. Then I accompanied them to Jaipur, where we studied all the collection from Rayoli. Rayoli also they wanted to take one specimen, Rajasaurus.
Achha.
Rajasaurus was not described till then.
At that time?
Oh. Because they were, excavations when GSI did now, there were at least 9 excavation queries. Almost of this size. And from each queries, the collections were different. So from query collections were different. So it's, as you know, what is this mixed? So in one of the queries, there was a mixed collection of titanosaurs and theropods. He said, so he immediately picked up and he said that these are the bones because they were experts.
So their one visit revealed a lot of things.
First he thinks. Said data mix. He's near theropods, but he said that I will work out. It can be something different which is described from the Jabalpur and all. So we went that, and then it took time, and then that was scanned. And we know what is the disposition, orientation of both inside the block. And when we knew how the bones are occurring, then you have to adopt a strategy and plan how best you are approaching the specimens to develop this. So there are mechanical, and they have got to be very advanced. They use ASKIs, which a lot of pressure, where that hammering is there.
Okay.
Small, we call the ASKI.
Like micro hammering.
And then it is all under the big microscope. That is also there with me, that we do. We did recently. And there are hoods. Whatever dust and particle we are handling, it is immediately scoped up and taken it.
Oh, like a vacuum.
Like vacuum. They took it. Okay. I took it. And then it's so fast. It can remove the matrix all around the bones and even from the bones. And they are just looking at the microscope.
Okay.
So they are very particular. And then it will also need a chemical.
Okay.
Because some of the matrix, which will not come up, we have to dissolve it in the acid. So we have to look what type of acid we are applying and with what strength.
That it should not be so corrosive.
So corrosive,
damages.
exactly. And then strength. And then every time for different experiment, we'll take some other working specimens, how it is reacting, the bones. And then every time the specimens, we will keep it for days together because the acid takes a long time. Because we will put it in a very dilute condition. 3%, 4% acetic acid or formic acid and things like that. And then very regularly, we'll prepare a plaster cast.
Just in case.
Just in case. After say 15 days when we have prepared the specimen, so that even if some damage is there, we have
at every level you have a plaster cast.
Exactly. So that technique is not there because even producing a cast, these are not just a cast, they are the research cost. Even if a small foramen is there in the vertebra, I will get it in that.
It's very accurate cast.
Very accurate cast. So these are all none in India. It doesn't exist.
We don't have any labs.
Any lab. Even if India, I'm telling you, even if I want to guess the scientific cost of this particular fossil or this cup, it becomes very difficult. Because there is a choice of you have to select the right cut of material, which will not shrink. It will not swell.
Right.
It will not flow.
Right.
So consistency is the same like that. So all the properties of that material, resin and other things that we add to that. So that is a very perfect and very accurate procedures, and they will apply all the vacuum chambers from where they will suck out all the oxygen and air from that, so that nothing remains inside when they are
nothing oxidizes.
Nothing, no oxygen or air molecule. So that is that material which you are using, there is a chance of that. So very accurate cost, that is what they call research and scientific cost. So they do it. So that was the preparation technique. And then after that, once the specimen is prepared, again we have to CT scan it. Taking it again to those. There was the medicinal institute attached to that. So they had that sort of a joint.
So they have a lab and then they have another institute.
Institutes attached to that.
Right.
And they were doing that. And then again they will advise, sometimes they will change it. So this type is not possible in India anywhere. We may talk something even in statistical, we don't have such thing. We have to be very critical. Mechanically we do, same we use some tools. Which tools mean some chisels and some needles of different sizes and some acid treatments like that we try to do. But this specimen snake, it's such a delicate thing. It is very difficult. Then we come out. We were able to, when we prepared these specimens earlier.
And how long did it take for this entire preparation?
It took almost
6 years.
No, it took almost, for preparation it took almost more than 2 years.
2 years.
But then further that photography, image analysis, taxonomic description, it was because they had a lot of material to compare. And they believe in the things that they are different, because if I find some fossils and I'm trying to identify it, unless I do comparison how the other specimens describe somewhere, I simply go through the papers and try to compare with my figures. It looks like that. But there they have all the collections in their museum of actual casts. So I think actually see the cast of the specimens.
It was that accessible for them.
Accessible, exactly. Or immediately they summon it. Like American version of HLST. Cast is available within second day it comes to them. So like that everything is available.
So the first cleaning up the entire thing took 2 years, and then identifying
it took photography, imaging, they have to do it, and then identification. It was a big task there. And then the specimen 2004. And the final paper which we are able to make
2010.
Believe me, it was a very good. And the thing is that when we prepare the specimens, we got the skull, we got the brain case, we got the pterygoid. So it was entirely a different thing. And then we had to involve a herpetologist, a person working on
snakes.
Yeah,
he was a snake expert.
Because he has to anatomical.
He has to justify that this is
and how you are trying to interpret macrosomation. So when we found the skull and all, and we had described how because we were getting the multiple association in other nets also. If we think that these snakes that we had named as Sanajeh, that was nearly 3.5 meters. We got it life-size reconstruction there. They had a modeler, a fantastic modeler.
So we got to see the artistic rendition of
Tyler, exactly life-size in the position where we were getting the scale, where the eggs that has come in, that coil of those bones were there, and they reconstructed.
And how big was the snake?
3.5 meters.
3.5 meters. It's a huge snake.
3.5 meters, it's a huge snake. And then that skull and those things, and then we tried to describe it in that paper. And then when that MOU, I had insisted them that life-size model you have to present it to Geological Survey of India, so that people they appreciate it, visitors. So Jeff was little hesitant. He said that it cost some $18,000, Dhananjay. Because at meantime I said nothing doing here. You had a lot of money. What is there? It's a
you don't need it, but India needs it.
And then I also insisted you provide a casts along with the original specimens.
Yes.
So because all the time I cannot work on the original specimen, so they delicate.
Right.
To work out on the, he implied that.
So where is the original specimen?
Original specimen is in Nagpur only.
Huh?
Yeah. We did. It has to go to Calcutta, but it is there.
Can we see it?
Yeah, definitely. Sometimes we can make arrangement. But I had all wrapped it, pocketed it, and then in the suitcase, and then in the almirahs with label and those things. So then it was there, and then we published this in 2010. And then before he came and that big model, life-size model was brought, there was a press conference. We held it at Bombay, where all the press people, they came, including the Nature, their foreign correspondent.
Yes.
They came there, the science people and all.
National Geography.
All their Indian counterparts and all, they came. And they had a look at the specimens and these fellows. And then secondly, then we got another specimen. That we called it Sanajeh 2.
Really?
Yes. Snake 2. But it was only a skull and pteroids and things like that. So this specimen we found, we had a mystery that how this specimen 3.5 meters
was attracted.
How can attracted, and he is coiling around a egg and all, and how it was able to predate it. It has a skull is not very big. It will be hardly, I am telling you, 12 or 13 centimeters.
Okay.
Snout to articulation.
Okay.
How it was able to open it, and if you say that it was predating on hatchlings of dinosaurs, young hatchlings or juveniles. So then we had to study that.
That it used to open its jaw.
It was a flexible. Lizards even if you look at that, lizards skull and the lower mandible joint, each much closer. But in the snakes, macrostomaton snake like your pythons and cobra, there is flexibility also. They can have wide gap.
Right.
They can open it.
That's in an anaconda try to
yeah. And they
wraps it around.
And they can open it, flexible, open it, and they also do it.
Right.
So they can take it to the first cervical vertebra, and then they ingest it. And then it was for the first time that we found that evidence, because you were asking in what way this specimen is unique. So it was the first time that we gave a late Cretaceous snake 70 million years predating upon hatchlings. So everyone was curious, how is snake? And then we tried to explain them the mechanism. And that way it became a global significance. And then after that, they never got any evidence in the world of similar specimens like that.
Unique specimen
in the world. So that was very big. It took a long time for the research. But it was really benefited. And I still advise, let us not, whatever we know, keep ourselves and confined to ourselves. Because today I am, based on my observation, my interpretation, I am trying to give some description or interpretation of my inferences based on that. But tomorrow someone comes, he has a better ideas. He may have seen something else. So whatever today I am giving, I am not.
You have to accept that you may not know everything.
Everything. I cannot pronounce a geology. I am telling you in paleontology. I always say I never pronounce a final judgment. Because it is always there, something else, somewhere else. There are many discoveries going on.
So discussing with your peers.
India, and there are many similar specimens coming up. So you may come out with some different ideas. So that is how the science will progress. And that is how it came out. Otherwise, that specimen would have died out as juvenile specimens only. But with the collaborations, we were able to say that
solve this big mystery.
So it is really there.
Sir, I had written so many questions, but कुछ भी नहीं पहुंचे हम लोग. हमारी बातें इतनी interesting हो गई that I am so satisfied with the entire conversation. I don't want to ask any more of my written questions. We have covered most of it. The one thing that I wanted to close this conversation was on the future of Indian paleontology. Sometimes these things will look very dismal and thoda sa disheartening when it comes to Indian paleontology. What do you think needs to be done with the education of paleontology or the kind of government actions that need to be taken?
You see, as far as the Indian paleontology is concerned, there are many universities and institutes where these paleontology
courses are
there. But if you look at the earth science institutes, where they are really pursuing the paleontological researches, there are very few universities like an organization like Geological Survey of India, and then Indian Statistical Institute, and then you have universities like Delhi University or Chandigarh universities where they are, and maybe even Institute of Science like what is there in Roorkee and all. But now the picture is that the paleontologists, as far as the vertebrate paleontology is concerned, it's a dwindling. Even the focus where Geological Survey of India, earlier the focus was on the research only. We were mapping and we were producing paleontological specimens. So it was all the research, and paleontology was a subject which has provided base for the stratigraphy. Because the entire stratigraphy, even mineral exploration and everything depends upon the stratigraphy, fossils, and how you are able to establish the stratigraphy.
So we are dating the age of the cross sections based on the fossils that we are finding.
Fossils, etc. So it becomes very important. But now, after the Geological Survey of India's focus is diverted, they are mostly now mineral exploration oriented.
Right.
So the paleontology there
has taken a backseat.
There it has taken a backseat. Geological Survey of India, Southern, it used to be a big vertebrate paleontologist. They are working on Gondwana dinosaurs that gave you Cretaceous. Very recently, we described a tail club of a sauropod dinosaur. Cretaceous, it was not known. It has a club defensive mechanism for early sauropod.
Like it used to use its tail as a defensive.
That we are able to publish in 2004 only. Jeff Wilson and Tariq Young students, they are there. So as you progress, but then the thing is that they are not right kind of expertise now available, especially the vertebrate paleontology. It is not, neither it is taught to that level in any universities. There you will find very few research students focused on these subjects. So by the original paleontological researchers, where these professional geologists and the paleontologists were dedicated to that.
Passionate about it.
It's not only bringing the specimens to laboratory and studying it. It is basically the field where they were staying in the field, trying to excavate the fossils, and then looking for many. They will download the specimens, wash it. Not only the dinosaurs, along with that, all the other fossils which they will bring.
Get their hands
dirty. Yes. So it were all the multiple type of things. So it was able to provide the better insights into what you are trying to look for. Not only the fossils, but as you said, as we discussed, fossils, how they, in what environment they lived, climate, what were the other environmental contemporary fossils. If they had the snakes, how they were living, what were the turtles, what they were doing, what type of turtles, what types of crocodiles. What was the total ecosystem there? What type of plants? So this comes only from the paleontologists who are exclusively dedicated to that sort of research.
Working in the field.
But it is not there. And that infrastructure, as we have discussed and you are asked, this advanced preparation technique, advanced lab. I am sorry, though we have spent a paleontological, but since the pre-independence era till today, after 1940s, we had hardly any vertebrate paleontology lab which can really boast up there.
Call world class.
World class. And that expertise is also because it's a very specialized domain. Paleontology domain itself is a domain. But then developing an expertise, say on dinosaurs or snakes or a turtle, very, very specialized. That is totally
missing.
Out. You cannot find it. And that's why it is very important for us and even advice for our students and young researchers, young career researchers to collaborate not only at the national level but the international levels where they are very eager to collaborate and work on our fossils because
they are interested in more in our fossils.
Because India is a treasure of these fossils. And there are many, it's like this snake which we have provided. New global snake as you asked, and the Pisura, diet of the dinosaurs, herbivores, actual plants which they were eating.
Right.
They are looking for many more such evidences, clues that will be able to provide. Or it will be some sort of a breakthrough in the research on dinosaurs. And they are very eager. But the thing is that we have also some government policy where they really club your wings. We are restricted. We cannot openly interact or collaborate with. There are many restrictions. It becomes very difficult because if I have to carry some specimens, carrying itself becomes very difficult also for permissions. And even if we carry it ourselves and carry it, there are a lot of problems at the airport, the customs, and then we were sending it, all the ministries, approvals and things like that. Most of the time you waste it in that. And then if there are certain flaws, and if a paleontologist has to waste all his time, as I told you, that MAU we conceived in 2001 and it materializes in 2004. We lost a very productive years in that.
That study could have been out in 2007.
So the scientists and the research in paleontology, you need to have all sorts of liberties. So you need to define some sort of a guidelines for that and directives. Because there are also some restrictions. There are many things which are coming as a geoheritage sites, field museums. Because you say in India, after that Gujarat find, that's a Raioli, where you get so many thousands
of... It's the only protected site.
Not protected sites, India government of Gujarat, but it is the only site which has a field museum. This is the field museum. A state of art where that we have 5D, 3D projections and digital forestry and everything. It's just beautiful.
Yes.
It's comparable to any of them, that is government of Gujarat only. But now they need, because the museums and the field museums especially, they cannot be like that. It has to be dynamic. You need to generate new collections and replace the old collections. And then you go on adding to the intrinsic value of that exhibits. So that is a problem. So you need to have a lot of change in the policy where all the expertise, not from the professional organization, but different earth science organization, and even if you say some protected area, I may be working in this area, I myself could have given some description, but if I need to revisit the area, there is restriction. I cannot dug any other specimen because that area has been declared as a protected. And if I do, that is treated as a criminal and I can be prosecuted for that. That is called the plundering of fossils in the site. You know very recently what had happened there. In Dholvira, that young students, Archaeological Survey of India, that Gandhinagar Institute and the Indian IIT Mumbai, they went together for collecting some fossils in the Dholvira archaeological site, which is Harappan site, which is protected. But then they went for purpose, but they had no permission, neither they bothered to inform the Archaeological Survey of India. It's a UNESCO site now. So, and that unfortunately, they dug a big pit there, maybe some 8 meters, 9 meters, and then suddenly everything collapsed and that young girl died there. And then, so it is very difficult. Why, if you are trying to study or take some sections, in sections which are already protected, people, researchers, young researchers, scientists, they should have some liberty to do
some
that.
Freedom.
But at the same time, it is also the responsibility
of these scientists
to take a proper permissions because they are also responsible. Ultimately, we have to protect the site, to protect our. For that, I am telling you, Geological Survey of India, Indian Museum, whatever collection has been done for the dinosaurs, for all the fossils in India, right from Himalaya to Kanyakumari. If you go to GSR, you can find at least more than 1 million fossils of animals and plants. You can just imagine a workload where Geological Survey of India, they have to curate these fossils. And when you go, sir, I want this specimen, they have curated this particular fossil. It's very challenging.
So it's a repository of
10
lakh specimens.
10 lakh specimens. And then they have computer here, they have put digital. And if you are interested in particular specimens, you just put it online.
Search.
And search it, you put it that type number, and they will try to tell you. They are even this 3D imaging, they have done. Put photographs and they will tell you.
Like a database.
So they will tell you the status, you can go, they will
Collect
archive it for you.
Oh.
So these things are not here in India. Say I am doing a particular research in institute, it is a professor. I have a project. I get a project from Department of Science and Technology, which now I am in Department of Geology. Or I may get from Ministry of Earth Science Environmental. After I retire and I have these two projects.
They're not letting you go.
But the thing is that when I collect, these projects are given to me. Dr. Saman, she was there with me. She was curator because institute's KIO. But what happened to my collection which I had collected in course of these 3 years of my project? 3 years of MS, 3 years of that. And the thing is that is not my private collection. I always prohibit people and tell them, what I have collected, never say in the meeting, inside and all.
My collection.
Come on, don't claim that. It's your collection. And if you have considered any project and you propose, you should be able to identify. Now we said it's my collection. I said that DST project, it's a government of India money. It's a poor man's money. You should be responsible for that. Each fossil cost us so much to you.
Taxpayers'
So it
money.
is your responsibility, and the university or the department where they accepted the project, because it will move through department only. I may propose it.
Right.
But it is the department, the head or the professor or the dean will propose.
It is a collective responsibility.
So once we accept that, he has to provide that also. But I am worried about specimens because I put a lot of efforts and I know the significance. But those type of facilities all over, because we were trying to put, and there was a meeting caused by the chief advisor, scientific advisor to Prime Minister, Vijay Raghavan and all. Mitra, and there was a big meeting of big stalwarts. They wanted to bring museum of time, the museum of earth. They wanted to bring that, but it could not materialize. There was all this concern because all the people, they were telling what happens to our collection.
This is my collection. This is my collection.
And they were telling, sir, if I retire, there is no flaws. It is all thrown. They were telling it. This collection, this project that we had completed in 2019, it has been thrown away. So who will take responsibility for that? So they wanted to identify where they can identify responsible people, and there can be
create some sort of a
department, museum, and this specimen has to go. So, but the thing is that what in the context which we are asking me. This paleontology is gradually losing a focus and thrust in not only in the professional organization like Geological Survey of India, Indian Statistical Institute, and various institutes, universities, including Institute of Science, and we are not really able to produce or generate new expertise or experts in the paleontology, and it's gradually dwindling down. That is the picture to in my opinion is very dwindled, and then unless we come out with certain policies giving some sort of a fillip to this research, it will be very difficult. And we need a lot of scientific liberty because in environmental concern, the forest laws, they do not allow us to do many labor. If I go to particular area, I found some fossil after hunting this area, and I need to excavate that area, I need a lot of permissions. And then environment people, forest people, they will not allow me to do that.
There's a lot of red tape.
And there is no wonder. Even I have seen, I can be handcuffed and taken to the forest. That we have seen it here. Pune and our own people and all. So it becomes very difficult. We need certain legislation at the parliamental and new guidelines where this will be proposed. And definitely with a new look, new research, new labs, and young students.
Indian National History Museum.
And a lot of international collaborations, interaction, and that sort of thing that needed. And of course, as we discussed, we need a lot of advanced laboratories to do that.
It's a long way to go.
That can come only with the expertise. And that's now we have to look for only in the young researchers because we are now on the other side. We are dwindling fast. But we feel regret and feel sorry that we are not really able to generate that kind of expertise or specialization within this specific field. It's very difficult. That is not only for the dinosaurs, but even for the plants and all other mammals.
Paleo-environment.
That sort of
thing. A very sad note to end this conversation on, but I think you have to stop somewhere. Yes, accept that.
Yeah.
Well, thank you so much, sir. Thank you so much for doing this, for blessing me with your presence once again. I'm really, really, really grateful that you are here and you gave me so much information. Do you have any feedback for me before we end this conversation?
No, thank you. I will look now because I always look for some sort of an interaction, not only with the professionals and this media, but also with a lot of students in the museum. Yeah. And if you ever get an opportunity, because we try to hold exhibitions, especially with the students, not only at the school levels, but even in the colleges and to seminars. And I always look for such opportunities. Yeah. And whatever fossils and little available with this, we always try to display it, and we see that students at different levels come and observe, and we are able to generate a lot of curiosity because lot of wrong messages goes there. Because when we say dinosaurs, everyone talks of a Jurassic. They think that, but Jurassic has a specific. So there are many wrong conceptions and wrong ideas, wrong signals. It goes into these young minds. So if we can clarify and through your media and such interactions, I think we can always try to educate the people. Yeah. And thank you so much, Eliman. And you can, it will be my privilege if I can be of any further.
Yes, sir, definitely.
And thank you so much to you and Akanksha also for that. Really, I was really thrilled for that. Thank you so much.
Thank you so much.
Thank you so much.
If you learned something new from this episode of the Horsemouth Podcast, do rate and review us on Spotify, Instagram, X, or wherever people engage with you the most.